Thank you all for coming to our Sustainable Horizons Symposium. This is the commitment of the American Ceramic Society to the International Alliance of Societies for a Sustainable Future, where ACerS is one of the founding members. So this is relatively non-materials, technical material science symposium focused on the sustainability, especially as a part of education, communication, right? Even if we work on the sustainability, we need to be able to convey our results to a larger population, as well as be able to educate the next generation of people on these topics. So we would like to also thank the American Ceramic Society for hosting this symposium, as well as allowing us to have this as a hybrid format. This is the only hybrid format symposium in the conference. We would like to especially thank Andrea for arranging many of these logistics for us within the ACerS. With that, I would like to first introduce our first speaker. And it is Tony Marashall will be talking about process intensification, circularity, and hacking the supply chain.
Hi, I just wanted to make sure everyone can hear me and see my slides, if that's okay. And I just want to, that's great. I just want to introduce myself. I work at Booz Allen Hamilton as a subject matter expert in the Department of Energy in the ARPA-E, which is the Advanced Research Projects Agency for Energy. And let's see if I can change my slides. There we go. And as the first speaker in this, I of course have to start with the slide showing the circular economy and how the concept is just really being accepted across the board. But how we're going to accomplish a circular economy is the thing that nobody really understands how to do very well. But I also want to go backwards a little bit and show you a little history. This is a figure from a report the National Academies issued back in 1970, which was called Materials and Man's Needs, and basically was the thing that established the discipline of material science. And what was happening at the time was that the industry was learning that if you put people who are metallurgists, especially extractive metallurgists, chemistry, mechanics, and physics in the same place, you got more synergy amongst them than individuals working within their own disciplines. And so they asked universities, and especially the government, to help them create this discipline. And so that's when the National Science Foundation started funding materials research laboratories, MRLs, and we started establishing these departments. And so it's really was a materials-driven idea that got us into this whole circular economy idea. And of course, it's been a challenge since then, but now we have even more challenges, which include our supply chain. And I know a lot of you have seen some of these headlines over the past several months, over the past year, really. But this slide on the right is a report that's issued annually by the U.S. Geological Survey. It's called the Mineral Commodity Summaries. This is from 2023. I think the 2024 one is out. But this is, if you look at the top of this, it shows the net reliance of imports. So across the top, the number one, arsenic, we import 100% of the arsenic we use. We import 100% of the asbestos, 100% of the cesium, fluorspar, gallium, graphite, so on and so forth. And down at the very bottom, we only import about 20% of our cements. And so this is an issue because we're constantly being blindsided by
I'm in the Zoom meeting. It looks
shortages.
Just fine.
Excellent. We're constantly being blindsided by new materials being added to this list, new export tariffs on that we issue, that other people issue. And so we really need to understand our supply chains a lot better. And when it
Morning.
comes to supply chains, what we're really talking about is life cycle. And that is the way that we need to not just look at the life cycle of what comes into our manufacturing plant and what comes out of our manufacturing plant, but where it comes from upstream, not just the materials, the energy, and where things are used downstream and how they get there. And so life cycle is a evolving with more knowledge as a discipline and as importance. And I just wanted to just talk a little bit about the project life cycle. I know many of you have seen these things before, but I think we really need to start looking at these things more carefully about where we draw the circle. Is it not just what we call gate to gate within our manufacturing facility, but cradle to gate? Where did our feedstock come from? So include our materials and the manufacturing costs, and then cradle to consumer. How do we get the product after we distribute it, after we manufacture it to the consumer? Cradle to grave, what happens when we use the product, how much energy it uses, how much waste it produces, and then finally cradle to cradle, which is going to include the recycling cost. And these things are sometimes included when people look at life cycle and not, but not always. And I like to use the example of manufacturing vehicles. When you make a car, you can make it very, very lightweight. And when you make things out of, say, glass fiber composites, which are very light for the body structure, but it also makes it much harder to recycle. You can make it out of steel, you can make your engine block out of cast iron, very easy to recycle, but you're going to use more energy during use because the car is heavier and we use more gas. So it's just a lot of trade-offs that we need to just understand a lot more about. And I just wanted to point out that the consumers have a voice in all of this too. So the consumers are now asking, give me some more labels on the product I'm buying to let me know where it came from and what happens to it when I stop using it. And this is something that I don't think people really understand either, is that everybody thinks recycling is a very strong part of our economy, but sadly, no. We see at the top of this chart, lead acid batteries, 100% recyclable. Why is that? The answer is because in 1996, the US government passed a law that mandated that lead acid batteries must be recycled. Prior to that, they were not. Yard waste and paperboard, we do recycle a lot of that. It tends to be very local and it is definitely useful, but it's not 100%. And then we get to the things, the engineering materials that we're talking about, like consumer electronics, metals, and glass, where we're just not recycling nearly as much as we need to. And, for various reasons, consumer electronics, certainly a place we use a lot of our technical and exotic materials and elements, but very hard to recycle because they tend to be just very buried within the materials. Metals, even, you think many of you might have a metal beverage can with you to drink a soda, but we don't recycle very many of those. For a lot of reasons, post-consumer collection is very difficult for metals and glass. Glass, the problem is transportation weight is very high. So it's just cheaper to use virgin material. But metals, the amount of aluminum in a aluminum beverage can has decreased dramatically over time. They're much thinner and stronger than they used to be. And so the ratio of the coatings and the paint to the amount of aluminum is different. And then, of course, people also insist on tearing off the pop top, which needs to be recycled with the can to get the right alloy out again. Sigh. And then finally, I have to mention plastics, where recycling has just failed. The manufacturers of plastic bottles optimistically put a little tag on each of them telling you what kind of plastic it was, so it could be recycled, but we recycle almost no post-consumer plastics. The about 10% that's currently recycled is basically from or we call it prime scrap or runaround scrap. It's scrap from manufacturing plants, so when you bale it, it's a well-known commodity versus post-consumer, which is a lot of other things that come with plastic. And I have to, say that 2018 was the last time the U.S. Reported this data. We're hoping that someday they will report more of it again. And then what are our options when we start trying to solve these problems? And this is one of my favorite Ashby diagrams. For those that haven't seen an Ashby diagram, this is Mike Ashby, brilliant metallurgist or material scientist, started putting together these diagrams back in the early 90s. And these are showing strength versus density. And you look in the upper left, you see this is around 1500 AD. These are the materials that people had as options to work with. We had natural materials, we had cork, wood, leather. We had ceramics, including bone. We had concrete, certainly pottery and glass, and in a limited number of metals that we definitely knew how to get out of their ores. If you go to the right, to the upper right of this, you see in 1900, you start to see expansion, more light metals, a few more ceramics. But when we get to World War II in the lower left, 1945 is when you really start to see engineered materials come into play. We see a lot more metals. We see a lot more, we see polymers start to appear. And then today, if you look in the lower right, again, strength versus density, we see technical ceramics have really expanded. We see polymers have really expanded. We've learned a lot about foams and the fact that you can get strength without weight. So we have and a lot more overlap. It's not just three separate blobs. It's a lot of blobs on top of each other. And so when we start to design, and I'll show you the next slide, this is strength versus the relative cost per unit volume across the x-axis. And the point being is when you start to design a new product or a new use of or a new application that you need a material for, starting with the type of material you want to start with is maybe not the best place to go. You really need to start thinking of from the entire life cycle. What are we trying to, what role does that material play, and what are our options? Because we have a lot more overlap and a lot more ways to engineer materials than we certainly used to. And so there's three things I really want to talk about today, and what's our opportunity in materials innovation. So we look at the structure, processing properties, performance, the tetrahedron there over on the left. I think everyone understands that those four things are highly related, that you can't get performance without engineering the process, the structure, or the properties. And so our innovation opportunities are in optimizing for domestic sources, vertical co-design, and I'll explain that again, and some process innovation ideas. So I wanted to first talk about what I call the purity trap. So when a chemist or when somebody in the laboratory says, I want to develop a new process, they order pure chemicals from their supplier, and then they develop a process, and then they hand that off to industry and say, here's how to do it. And so in the case of neodymium iron boron magnets, which are the permanent magnets that are probably 60% of the market and make a lot of our motors what they are today. Motors don't work without magnets. But what we do today is we mine our rare earth elements, which are hidden in the periodic table, elements 57 through 71. They're hidden in a little box. And so we're talking about cerium, neodymium, praseodymium, and all the way down the line. And right now, what we do, the first magnets were made with pure neodymium. Now, I just want to mention that it's very hard to separate rare earths. They're all very chemically similar. In fact, when they're mined out of the ground, we call them mish metal because they're really they're all there in various quantities depending on the deposit itself, but usually every one of them. But we determined over time that maybe we didn't need to separate the neodymium and praseodymium. But interestingly, we still have to take that down to purity with no iron, at which point we give it to the magnet manufacturers and they make a neodymium iron boron magnet, which is 70% iron. very frustrating. But we at least made the step to not separate the neodymium and praseodymium. They are different elements, but they are very complementary, it turns out. But the question then is, what about cerium? Cerium still contributes to magnetism, is a lot less expensive. We would save the cost of separating it, and we'd probably still make a good magnet. So, which would help in many applications, and we wouldn't need to go to the very high strength neodymium iron boron. Also, the heavy rare earths like dysprosium and terbium help a lot with high temperature properties. And right now we separate them all out and add them back in. But what if the natural abundance in certain ores might be good enough for an application? And so these are the kinds of things that we're hoping that materials and engineers start looking at. Barium titanate, another very common ceramic material that's used for piezoelectric or ferroelectric applications, is made by mixing 1-to-1 barium carbonate and titanium dioxide. And so then over here in the upper right over there, we see doping, at which point they add things like calcium or strontium or lead and a lot of other things to tune the electrical and the temperature properties of the material. But look what comes with titanium. Calcium, what comes with barium, strontium, calcium. Why do we take those things out, ensure these two things are 100% pure, and then add the modifications back in? This is clearly something where we could be a little more, well, like we call it, vertical co-design. And this is what I'm talking about. We take our domestic ores and feedstocks that we know where they come from and we have control over them. We go through the concentration and separations and reductions and synthesis. But what if we could do more end-to-end process design, align the design of the process more closely with the available feedstocks? And then the other thing with the vertical co-design is to start including all your co-product and byproduct economics at the start of the process. I mean, many processes today, many, especially startups, are told by their investors, focus on just one product, one exit strategy, no paying, no trying to do too many things at once. But by doing that, we end up with a lot of waste and with valuable products in it. And so this is another thing that we need I think as a country, need to start thinking about more. And then process intensification on the left, how can we look at new processes, and I have some ideas on that, to look at things that are more continuous versus batch processes, and not just incremental improvements of individual steps, but how can we just skip steps? How can we go directly from ore to product? And we have some ideas. So this is some of the ways. I mean, we have a lot of new energy options to get there. I have to point out geologic hydrogen. We can take it straight out of the ground and use it rather than try and generate it using electrolysis. There's a lot of other interesting ideas out there on new energy sources. Certainly nuclear is coming on strong. But we also have novel chemistries. We have bio-assisted processes. Electrochemistry has made amazing strides over the past, I don't know, dozen years. And we're now looking at things like directed energy, like microwave plasmas and laser technology, which can take us, really give us a real boost versus traditional hydrothermic or hydrometallurgy processes. But then we're looking at, we need to look at our sources and we need to look at process intensification. So this is the way we're trying to frame the problem now. And so here's a process that we're looking at today. A couple companies are already trying this, to look at, and that top middle process here, I think you can see is a sort of a vision of a rotary kiln that if we can take our US sourced ores and feed them in here with things like microwave plasmas or lasers, or just a whole new way to apply temperature. How can we increase the production rate, decrease the energy production, and produce things like our nickel metal cobalt cathode active materials or our lithium iron phosphorus cathode active materials. This is going to be really interesting. And one the other way. And so they also wanted to point out, this is a really interesting slide that a company called Limelight put together, Limelight Steel. If you look at the way we made steel back in 1700, for the energy source, we used wood, basically, that we burned into charcoal. And so we used biomass. And, sometime across the last 100 years, we switched to fossil fuels and use coal and coke for steel making. But today, especially in the US, 70% of our steel is made strictly using electricity. We don't use fossil fuels or biomass. And so we've changed our energy sources over time still and produce our steel a lot more cleanly and better. But the other interesting way to look at this is the energy sources for lighting. Again, we started with biomass. We moved to fossil fuels. We moved to electricity, but today 50% of our lighting is LEDs. And so we can make these changes over time, and we need to start innovating in order to do that. And I should go backwards. And so where are the tools? This is the biggest tool I think we have, which is AI is going to be transformational. But I have to point out these two great quotes that are in this Nature article. If you're not using these kinds of methods within the next couple of years, you'll be behind. But also, it's not like someone can just simulate a material and it becomes an incredible product. 100% true. We need a lot of engineering and thought to apply these tools to the kinds of processes we're going to need. And this is just the example. If we were trying to come up with a new magnet that either uses rare earths or doesn't, and when you just start with the periodic table, you end up with hundreds of thousands of potential high entropy alloys that could work. We don't have the time to try and fabricate every one of these. We need better modeling and systems to be able to do that. And finally, I just want to finish with a little, bring this back to life cycle analysis. These are the things that we've traditionally thought life cycle analysis can do for us, is show us how to feed things from one process to another and how the trade-offs work. How do we show the impacts? How do we compare one approach to another? And how do we use a standard approach to be able to measure things? But I also want to point out how the government looks at this. And we need more and better LCA of all processes in order to understand the supply chains, in order to try and understand emerging and existing technologies and to compare them and look at future scenarios and be able to plan ahead and make our investments more intelligently. And so I just wanted to end with my information. Please friend me on LinkedIn. Happy to answer any questions, and I would love to talk further.
Tony, let's applaud our speaker. So first of all, are there any questions from the audience?
Hey, Tony, thank you so much for the very nice presentation. So when you mentioned converting energy sources, that helps us tackle scope 2 emissions. But when we look into this emission intensive industries like the steel industry and the cement industry, they have these inherent emissions which come in through their processing, which has been there since forever if we look into the iron and steel industry. So what will you suggest that we should look into to tackle the scope 1 emissions when we're using hematite and coal since forever to create our iron and then converting it to steel?
I totally agree. The steel industry, steel is very, very, let me stop sharing. Steel is really efficient. Blast furnaces, it turns out, are like 97% thermally efficient and 98%, materials efficient. They're really good. But we have a lot of new ideas on how to do this better through plasma processing. And I'll point out the ROSI program here at the Department of Energy and a lot of other places. We're looking at a lot of electrolytic processes. Can you process, instead of with methane, can you use ammonia as a hydrogen carrier, not with carbon? There's a lot of novel ways to do this that we need to start looking at more seriously. But yeah, would be nice to get rid of blast furnaces.
I have a question. In the supply chain, the upstream, downstream companies don't talk to each other, and to make a true life cycle analysis is very difficult. Is there a place for government? Is there a role for government to play to make this happen?
I think that people are thinking about it. I will point out another National Academy study that was back in 2008 called Materials Count, where we talked this is a long time ago now. I'm old. But we talked about the government's role in trying to track where materials come from and where they go, because there's just a whole lot of waste materials that people treat as hazardous waste that are very similar to input materials for other processes. And we really need to figure out how we can tie that stuff together. I mean, I think you guys know the recycling industry is very, I mean, anybody that can, the scrap dealers, I don't know what to call them anymore. The guys that can look at a pile of steel scrap or a chemical waste and say, this is valuable, and how valuable is it? Right now, it's not very well documented. It's a lot of guys who know what they're talking about. It's black art. There's a word I'm looking for. So how can we start, really starting to look at what's in all the waste material we have and reclassify it as feedstock? I think that's going to be really important.
Let's thank our speaker one more time. Thank you, Tony. Our next speaker is joining us from Germany in Technische Universität Darmstadt, Yannick Gehlen.
Hi, everyone. Hope you can hear me all right. Let me share my screen. Can you actually see my screen right now?
Yes.
And the presentation?
On
Is that
screen,
okay?
yes.
Issue mode.
Not sure if this works. I have it on full screen now. Let's see. Yeah, so if you can see my presentation, this should work out. So I'll just start. So thank you very much for the invitation, and thank you for attending this very short but hopefully interesting session about a very different topic than we've covered before. My name is Yannick Gehlen. I'm actually right now from University of Düsseldorf. I just changed a position. And I'm a sustainability scientist with a background in philosophy and sociology. So today I want to invite you all to a little, say, reflection exercise about a metric that is very ingrained in our culture, but yet not often reflected or questioned. And we're talking about GDP, the gross domestic product. So the title is Rethinking Well-Being and Sustainability Beyond GDP. And I will talk in 3 chapters. First, I will give you a little introduction about the origin of the concept. Then I will talk about the cultural dimension of GDP and how it has actually infested our brains and our minds. And then at the end, I want to give you some alternatives to GDP. So let's jump right into it. Chapter 1, the birth of GDP. So what did actually happen historically that the gross domestic product could become such a prevalent metric? So basically the GDP...
Yannick, sorry to interrupt. Yeah, there we go. We weren't seeing the slides.
You weren't seeing the slides? Oh, that's bad.
Now we do.
Now you see them? But now I don't see them. Okay. I don't know what's the... Let me do this again. So when I open PowerPoint, you don't see them. And when I open Zoom, you see the slides. This is weird.
We were seeing the slides, but they weren't moving. We were seeing the sorter and the first slide.
Oh, I see. So, sorry.
Right
So
now
now
we
the
see
slides are
them.
not moving?
We see them right now in slide 3, not in the presentation mode.
Oh, well.
It is okay as is now. It's just the slides weren't moving, so we were stuck in the first slide when you say chapter 1.
Okay, but now when I jump, you see the jumping?
Right now you're at 3. If you go to 4, let's
Well,
see.
I'm switching actually to test it, which doesn't work. Okay, so whenever I change a slide, I will change it like this.
All right, now it changed to 4. Yeah.
Okay, so I shouldn't go full screen. That's the solution. Sorry for all this, guys. Let me continue. Okay. So back to chapter 1, the birth of GDP. So the concept was invented by Simon Kuznets, an economist in the 1930s, and he got commissioned by the US government to create a uniform system of national income accounting, which he did. And it proved to be very helpful during the wartime because all of a sudden we had a metric and the state officials could ask questions like, how many bombers can we still build without starving the population? And these questions turned out to be very important in this wartime. And then in the post-war era, for some reason, it became the standard metric for international trade. And also for the Cold War rivalry, it became important because now the opposing regimes could actually argue, as long as my GDP is, say, above the Soviets, it's a proof that my ideology is also superior, which is a bit twisted, but this is how it got so popular. So, and then step by step, GDP became the world's economic operating system up till today, actually. So let me give you, I hope you see the change of the slide. Let me give you a short overview of what actually goes into the GDP. So it's a sum. And first of all, it encompasses personal consumption, so that what we buy every day, you and I, this is a very big chunk. Then we have the government spending. Then we have business investments, so private investments. And then we have the sum of exports and imports. These shares on the slide are just exemplary, but they pretty much reflect the share roughly. So the definition, the technical definition would be that GDP is the total market value of all final goods and services produced within a country's borders in a specific time period. So final goods basically means that you count the car and not the parts of the car, right? So to avoid double counting, basically. And if you're into maths, you can also check out the formula. So GDP is the sum of the consumption C, the investment I, then you have the government spending, and then you have the net export, which is export minus import. But that's just technical. So in other words, it's basically the flow of money within a country's borders, right? Whenever money changes hands, the GDP increases. So this is the basic introduction. So let's jump to chapter 2, the hidden costs. What is actually the problem that GDP has become the metric that it is now? So funnily enough, Simon Kuznets, the inventor of the concept himself, has been rather terrified when he noticed how state leaders started using his concept. And he famously said that the welfare of a nation, so the well-being of a society actually, can scarcely be inferred from a measure of national income. And that was back in the 1930s, right after he invented the concept. He said, stop, guys, it's not a measure of welfare. 34 years later, more famously, Robert Kennedy also argued against the GDP as a metric for welfare. And he said that the GDP measures neither our wit nor our courage, neither our wisdom nor our learning, neither our compassion nor our devotion to our country. It measures everything, in short, except that which makes life worthwhile, which I find hilarious because politicians today still chase GDP as like the most important measure of a country's success. And yet back in the 1960s, we already knew that it's not that simple, basically. But you might still wonder, so what is the problem with GDP? because to some degree, it does work as a proxy for well-being, right? So it does correlate with positive things like employment rates. So if you think a healthy society should have a higher employment rate, then we can easily use GDP as a proxy for that. It also correlates with caloric intake, so people don't starve anymore, they get older. It correlates with literacy and medical care and many other things. So you could actually say that this little curve on the right is an indicator of societal success. Why wouldn't you think that, right? I want you to memorize the structure of this curve you're seeing right now, because the truth is, it doesn't only correlate with what I just told you, it correlates with everything. So this is, okay. So actually the slide should be different. First of all, you should see the other trends. Okay, we're going to take it as it is. So this is what we call the great acceleration in sustainability research. So after 1945, when GDP became the dominant measure, every societal domain that you look at, you see an increase. You can pick random measures. We have the population here on the top, but we have also funny things like McDonald's restaurants. You know, the curve always has the same shape. So society just increases its effort in every domain. And at the same time, you have Earth system trends, so ecological trends, that also show a similar shape of the curve, which is a problem. Because you can basically say as GDP rises, virtually every indicator of planetary stress rises too. So that's a problem, right? Then also you can say that GDP is blind because it doesn't distinguish between good or bad growth. It just says it's growing. And therefore it integrates money which is actually spent to fix a tragedy. Many of you might remember the tragic Deepwater Horizon oil spill, for example, which led to a sharp increase in GDP for the countries that were involved. And yet it was one of the most tragic ecological disasters we know of, right? You actually also can count natural disasters into the GDP, because if you repair a city that has been destroyed by a hurricane, it's good for the metric, right? Not good for the people. You can count car accidents. People who are chronically ill are good for GDP. And then also you have, for example, crime and war and the production of weapons and tanks and the rebuilding of the destroyed cities. And it's a whole cycle of GDP increase that in many regards is bad for the people. It's hard not to see that, actually. So what can we do? So chapter 3, Beyond GDP. I want to give you a very short glimpse of an idea of how we can think differently, both on a societal level and also on an individual level. So let me throw a little hypothesis to you. This is something I've been thinking about for many years, and I also find strong support of that hypothesis with a lot of authors that I'm going to present to you. But first, the hypothesis. In my opinion, our obsession with economic growth as a society, as a state, as an economy, but also as individuals, is the structural reflection of a culture that has mistaken the standard of living, right, GDP, wealth, for the quality of life. And I think the problem is that these two terms are so similar that you can easily think that they're the same, yet they're not. They're actually pretty much the opposite to some degree. And I want to give you some examples of very famous philosophers or intellectuals of the past 50 to 60 years that have made that point in slightly different ways. So first of all, we have a German psychiatrist and philosopher, Erich Fromm. You might have heard about him. And back in 1976, he published this book, To Have or To Be, where he distinguishes between two modes. On the one hand, you have the having mode, which I relate to the GDP logic here, which is defined by possession, consumption, and the accumulation of things, right? And here, success would be measured by the command over objects. And to make it even worse, this creates how he calls a dead world, where people are objects. Actually, we relate to people as objects. And at the same time, objects are valued above anything that lives. So it's a whole mess. And on the opposite side, he describes the being mode, which everybody of us knows as well. It's defined by presence, by activity, and the sharing of experience. And here success is measured by engagement with the world and not accumulation, right? So this is a better measure of quality of life. So this is a very classic distinction made by Erich Fromm back in the 70s. You also have a more modern approach by Amartya Sen, an Indian economist, who actually won the Nobel Prize as well. He defines what he calls the capabilities approach. So rather than measuring development of a society by accumulation of commodities, you could also expand human freedoms and call this quality of life. So for him, wealth or GDP for a society is only a means to an end. So he would argue that two people with the same income could have vastly different qualities of life depending on their health, environment, or social infrastructure. So, and then there's a third idea I came across recently. There's a German author called Hartmut Rosa. He's a sociologist, and he wrote a book about the uncontrollability of the world. And in there, he develops this theory that we as modern human beings follow a logic of command. And in this approach, you could argue that GDP measures our success in turning nature into a resource that we can control, right, rather than relate to. And thereby, we treat the world as a point of consumption rather than a place of encounter. He makes this distinction. And therefore, when everything is controllable, that means, for example, digitized or bought or managed, the world stops speaking to us. He calls this a resonance that we're losing. And I don't think it's a coincidence that high GDP often correlates with high levels of alienation and burnout. So I think as a society, we actually have to ask ourselves, what are we orienting ourselves towards? Is it only the accumulation of wealth, which would be GDP on a societal level and maybe material wealth on an individual level, or are there other ideas? And I want to give you a short glimpse to alternatives to that. Many of you probably have heard about the Kingdom of Bhutan and its gross national happiness. So they're actually the only country that have incorporated happiness into their constitution, which is amazing. And this concept integrates things like sustainable development, cultural preservation, environmental conservation, and good governance. I think the devil is in the detail, but it's a very good symbol and a very good message to other countries, I would say. And here, the decisions of the state can also be based on psychological well-being rather than just pure output, right? Material output. But I would also argue here that the fact that this was possible in Bhutan is not a consequence of the government simply deciding to adopt gross national happiness, but because the people were ready for it, right? So I think the responsibility also lies in the individual itself. Another one would be the Human Development Index. This is a very popular metric that has been widely applied already, but it hasn't replaced GDP completely, because here GDP is only a part of it. It also integrates education and things like life expectancy. And thirdly, I want to show you a concept called the donut economics. This is a concept or a framework developed by English economist Kate Raworth in 2012. And she basically took the concept of planetary boundaries, which many of you might know, which you can also see in the image. It's the outer layer, basically, the 9 boundaries. And she said, we have to also meet the needs of the people. So that would be the social foundation. This is the inner circle you can see in here. So we should avoid shortfalls in terms of the social foundations, and we should avoid the overshoot in terms of the planetary boundaries. And so for her, a healthy, striving society would be in the circle of this donut here, and that's why she calls it donut economics. These are just examples that are being in the discourse, but I think we haven't taken the idea of replacing GDP all too seriously, or at least adding something to it, so that we don't only evaluate our lives by how much wealth we accumulate as a country and as individuals. And with that thought, I hope that was somewhat provocative. I want to release you into the question section. As a last slide, I actually asked AI to create a picture of my topic, and I think it's rather cheesy and a bit cliche, but I think it somewhat captures what I've been trying to say, and I want to leave you with that. And I hope there are some questions. Thank you.
We have a question.
So I was wondering whether you have tried to apply this to any particular subsystem. So it's one thing to apply it to a country level calculation and a cultural shift. But anyway, I'd like to find out whether you've thought about
Right.
the subsystem that you would start with
Right.
to apply.
That's a very interesting question. Thanks for that. So the first thought that comes to mind would be that there are some subsystems that are more ready for such a orientation. What comes to mind would be education, for example. So I think this idea of the importance of quality of relations rather than accumulation of goods is very easy to adopt in education, because a functional educational space is a space where people relate to one another in a very positive way, and where things like where you come from, what's your financial status, or such things, they don't count as much. So education would be a subsystem where I think this could be applicable. Now, I think the bigger the system gets, and the state would be the biggest, the more difficult it is to actually say by GDP, because it has some functions also in in an international context. So that's why I think we should also start with ourselves, right, where it's the easiest to adopt it. But I like your questions, and I will think about it more and take it with me.
Okay, because I'd like to talk with you about this more, because Elinor Ostrom, I don't know if you know of her, 2009 Nobel Prize, she actually has a framework for developing sustainable self-organizing systems, and not just individuals, but integrating it and teaching. And so anyway, I'd like to talk with you more about it, because I have an example of where we've applied it.
That's great. Love to talk to you more.
Thank you, Carol. I think we have an online question from Jürgen.
Thank you, Yannick. So you have shown some books, but which book should we read if we want to find out something more on well-being? Kate Raworth is a little bit abstract. What do you recommend?
Yeah, this highly depends on what you think well-being should be, right? So you could argue that you should read the World Happiness Report, which is about well-being, but this also only gives you metrics, which I don't think we need in the discourse. I think we should talk more about the concept itself. I actually would say we have to reflect collectively what well-being should be in the future, because the old concepts, they don't work anymore. So I cannot really name one book where it's all written out. I think that we have to come together and develop the concept. But having said that, I'm a big fan of Hartmut Rosa, and I've just got you into the boat to read him as well. So I would always recommend Hartmut Rosa. I can write it in the chat. There are also English versions of his books, because he really tackles the idea of our society having a wrong orientation, and he gives counterexamples, which I quite like. But if more comes to mind, I can also send you some titles.
Okay, thank you.
Nick, I have a question. So one attraction of GDP is, of course, it's quantitative, right? It's a number. We are used to looking at those. But when we talk about happiness and measuring happiness, even the education, we have all kind of tests and metrics, and then we come with a new plan, change it, and suddenly education in a school that used to be good suddenly looks bad because we changed how we measure it. So how do we deal with the more qualitative nature of these other factors compared to the quantitative nature of the GDP?
Right. I think the biggest mistake would be to try to find a way to measure it and then measure it somewhat, because then you lose the essence still, right? So I think there are things especially like quality of relations, quality of life, also personal preference, like what makes my life good is different from what makes your life good. These things you cannot put them into numbers. I know that countries want that because they want to be comparable and they want to win some races in some rankings and stuff. But I think we should be cautious not to measure everything. But I agree that we have to find a way to evaluate if an institution, takes this approach seriously. But this can only be through qualitative, now I say the word again, measurements. You can ask the people how they like it in an institution, for example, and you get a qualitative answer. I think we don't need to measure it. That would be the short answer. But if you have a counter thesis, I'm happy to hear it, because I'm very critical towards measurement by nature, but I don't know if that's always applicable and useful.
Thank you. Are there any more questions? Okay, we have one more question.
So I was wondering whether you tied this concept of happiness to Maslow, and the Maslow levels, because it's one thing for us as Westerners to think about happiness, but Maslow begins at a very fundamental level. And also what the scope is of our calculation of happiness if we are exploiting other countries, for example. Anyway, it's a broader Maslow discussion. I just wondered if you thought of it.
Right. Yeah, it's a huge topic, and I wish I would have got more than 20 minutes to talk about it. So I like your question about other countries and other cultures, because I think we in the West have a very stiff idea of what makes a life good. And I think we can't really know what we are missing out. So I think this dialogue should also be intercultural. So that's the first part of your question. I think other cultures are more advanced in this journey of finding out what actually is life about and what makes life worth living. Going to Maslow. So I have the pyramid in mind right now. So. Would your question be that happiness is not part of this pyramid, and where could we actually put it?
I'm sorry to interrupt, but what I'm going to do is I will make a connection between you, Yannick, and Carol,
sorry.
To further this conversation, because we need to go to our next talk, and hopefully these conversations will continue, and then from this symposium it will lead to things that are bigger. Sorry to interrupt. So our next speaker is in person. It's a contributed talk from Rishabh Kundu.
Good morning, good afternoon, and good evening to everyone joining us globally. My name is Rishabh Kundu. I'm a PhD student at Case Western Reserve University. And in my, do I dare say, free time, because my advisors are in the room, I cater to activities that advocate sustainability. And this is the result of one of those very dear projects wherein we are trying to account university carbon footprint. So because I'm the first in-person speaker, I'm just going to test out the clicker. Perfect. Awesome. So universities or so-called college towns here, they can host up to 80% of the local population. And this means that we obviously cannot ignore them in any way. Despite this huge influence on our society or community, till 2022, as per an ACerS report, only 15 universities have reached climate neutrality in the United States. To give you an example, and I have nothing against the Ohio State University, I really like them. This is something which I just dug up. Ohio State University emitted 400,000 metric tons of carbon dioxide in 2024. And this is just a number, right? This is equivalent to driving an EV for more than 1 billion miles, or greater than 90,000 cumulative household electricity consumption in the state of Ohio. And Ohio itself, which is not that big of a state in terms of having educational institutions, has greater than 60 higher educational institutions. And this very message that we cannot escape the campus will be further elucidated by Dr. Fromling in one of the afternoon talks. So I'm going to save my time here. Is there nothing which accounts for the carbon footprints through the university system? That's not true. There are very well-established tools, but these tools are primarily research lab focused, which is where, from my intuition, I think the maximum emissions are specifically in the STEM fields, but there are university departments beyond the STEM fields. I have personally used LEAF during my wonderful time in Germany, and it works out really nice. And I know that many universities, including the Penn State University, uses the My Green Labs and their certification programs, and that works out too. And the ones which are available for the non-research lab activities, they are not open sourced. They're from, through some informal conversations, they keep on account of the traveling which the faculties and students, etc., are doing through airplane, cars, etc., but none of them is available to the public. You have to sign in through their website portals and stuff. This is where we come in, and we want to fill in this gap. And we are trying to develop a tool which requires minimum human efforts, because we cannot expect our already overstressed administrative staff to put in and go out of their way to do this. It's open source, so you can use it for free throughout without any obligations. And it also presents easy to comprehend comparisons so that you can take it up to your deans, provosts, etc., because they understand not just the numbers, the amount of metric ton carbon dioxide emissions you have. Specifically, if you look at this figure, we first sat down and we started sourcing our data. And we say, okay, what are we buying? What are we doing as a department? And I was fortunate to have the department chair support in this initiative. So this went really well. And we determined these incoming streams into 3 scopes of emissions, which are the popular ones categorized by the industries in general. Scope 1, the direct emissions, Scope 2, which is the energy and associated emissions, and Scope 3 is everything else. Then we looked into how can we model these numbers, which are the incoming flows, into environmental footprints. So we then catered to these existing databases as an attempt to not reinvent the wheel. And then we found out that there's a lot of missing things out there, which do not, so like for instance, if we are using a particular brand of a printer toner, we don't know how much carbon emissions that printer toner has. So we had to then model certain things, and then when you're modeling things, you also have to find out, we usually start from a very simple model, and then we try to complicate things and find out where the best fit are. And while they not be the best absolute numbers, they provide good baseline standards. So if you are doing your analysis for the year of 2024, it gives you the good baseline standard, and if you're using the same model, it will give you this Y for the next year, and the differences are very valid based on the actions you took from the insights you received from these models. And then, of course, the ultimate goal is to create a dashboard where any one of you can go and you can just see how our department is performing. The progress we have made so far, I would like to acknowledge the Office of Energy and Sustainability at Case Western here. They have been very helpful with us in their cooperation. And first of all is that we wanted to get the electricity consumption raw data, and we found out that our department building doesn't have a meter. They use models to estimate how much of energy we are using for that building, because a lot of buildings work on the same meter, because it is Case at least who is paying the bill at the end of the day. So we got that model information, and if you look at figure 1, there's a lot of data points which is missing, which was expected. And then from those over here, and if you see, there are almost more missing data points if you combine both the years 24 and 25 than data points present, which makes it extremely hard to predict anything. But we could do that using several attempts and a very nice Kalman filter. And then we also found out the energy mix of the electricity which we are using, so which comes from the Cleveland Public Power to MC Core and then to our campus. And then we converted this emission data, the electricity consumption data and the allocation factor from the energy mix we got, and then we have our emissions in figure 3. Are these the best results? I will not say so, but these give us good baseline standards. And now, over the spring break, we have a meter installed in our building, so we will have very precise, accurate data coming to us, which makes our analysis better, and we don't have to make predictions, but we can rely on actual available data points. Looking ahead, we will then focus on Scope 3 modeling. I already told you about the printer toner, food and beverages, etc. Our department likes to give out our grad and undergrad students some food before the seminar talks and stuff, how those affect our emissions. And then scope 1 modeling, which is basically we own some departmental vehicles, and when we use them, how does that affect us? And then ultimately we will develop a dashboard where all of this is amalgamated and the whole backend thing is available to the public. One very important thing which came up is that Case Western Reserve University, the Department of Material Science, can have X amount of emissions, right? X kilogram of carbon dioxide equivalent. But that should not be a fair comparison to something like the Ohio State University's emissions, because they're bigger in size. So we need to normalize our emissions, and we are thinking of ways as to how we can normalize this by the number of graduates we have annually, by the research spending we do, and we can do the same for other universities to actually have a comparison as to how we are performing. Because the numbers itself depend on how big your department is. The most sustainable department is the one which shuts down its doors and fires all of its staff and students, but we cannot function that way, right? And because we are catering to these efforts, our department has also changed its mentality, and then we have a very streamlined way of collecting data, because if you buy something from Amazon for whatever purpose, let's say a box of paper clips, on your final bill you see Amazon XYZ blah blah blah, and that really doesn't tell you how many paper clips you bought or something. So now we have a subsystem in place which records this, and then it tells us what we are exactly purchasing. So my take-home message is to you, and I will be happy to discuss this further, I don't want to cut off too much time from lunch, is that we want to find out the emission hotspots we have through a very data-driven method and not what our intuition says, and then act on it. And we want to make it open source so that first of all we use it in our department, then departments within the Case School of Engineering, university-wide, and then cross universities. And then we are focusing on the non-research aspect so that we are not already reinventing the wheel, because the research aspect is nicely covered by LEAF, My Green Lab, etc. So I would like to thank a lot of people who contributed to this. This was not an effort of just the 3 speakers there. So on the left, there's Jonathan Sterer here. He's the program director of Think Energy Fellows, and he has his talk later. And I got to know about the energy market in the United States, especially in the deregulated sense, a lot from him. So I'm really grateful. Then there's Krista Bailey here. She hosted us for 2 very nice conferences, the National Sustainable Society and the ACI conferences, and introduced me to those communities, and I really look up to her insights. And then our work was presented at the Midwest Climate Collaborative, and we got a Best Poster Award there. So that was already a nice achievement. This is the undergrad Blessing who is working with us. And of course, I would like to thank Heather from the Office of Energy and Sustainability, Jenny and Susnita from our department, my PhD advisors, Dr. Sally, Dr. French, and Dr. Rodel, who is my mentor. And with this, I would also like to thank the American Ceramic Society who made this possible, and all its great staff and great cooperation. Thank you for your attention. I think we can take some questions if the chair allows.
All right, do we have any questions? Oh, sorry. Yeah, thank you. Any questions? Yep.
Thank you for the interesting talk. I was wondering, so you want to compare different universities with this approach, but how do you consider that, for example, different universities and departments do different kind of research that consumes different amount of energy, for example? Like if you have a lot of furnaces that run at very high temperatures, your energy consumption is very high, but maybe you just have 5 members, so in general you would be very bad. And then you could have a department which works on something that doesn't consume that much energy. So how do you want to consider this in your approach when you compare the different universities?
Thank you for the question. Just to clarify, we are working on the non-research aspect, because the research aspect is covered by those tools which I showed, LEAF and My Green Labs. And on the non-research aspect, we will then normalize these factors based on graduates or research spending, as I was mentioning. And then that could be a comparison source. But also, as a further clarification, our main goal is to provide an accounting tool to account for carbon to the university departments and not compare but then there can also be a comparison, and the universities may be interested in that because our accreditation and rankings now also depend on the sustainability parameters.
Okay, thank you.
Hope that answers the question.
Thank you, Rishabh. And for the people in the audience and online, we, at the end of the afternoon sessions, we will also, there's a question?
That kind of relates to the question before. And speaking of ranking, Americans are very competitive. Is there a way that you can get departments compete against each other in a relative sense? Which department has most percentage reductions per year wins a prize?
So that is an excellent question, Jürgen. We already have that in case for housing societies or housing dorms. They compete annually for 2 weeks to reduce their energy consumption. And I do not see why the department folks cannot be, pumped up to do that. And I will really take this into mind as we continue developing this app. This was an excellent suggestion to hidden in the form of a question.
Thank you.
Jürgen, thank you, Rishabh. And again, after the afternoon sessions at 4:15, we also have the student competition that has judges voting as well as audience voting. So if you are here, you'll be able to vote on the student competition, which will be 7 competitors with 3-minute presentations each. 8 students' presentations. All right, see you in the afternoon. Thank you. Thank you all for coming, and those of you who are currently online. We're going to continue with the second session of the symposium. And our first speaker is Jonathan Stryer from Case Western Reserve University.
All right, I think we can kick it off. I can't see the room, so hello to everybody in the room. My name is Jonathan Steyer. I am the interim director of the Great Lakes Energy Institute at Case Western Reserve University. And I'm here with my colleague, Karis Eglin-Smith, who is the climate resource specialist at the Great Lakes Energy Institute at Case. And so we're going to cover a couple topics today. I'm going to kick it off by talking more about the framework that GLI is attempting to support and grow at the university, and then segue into some of the specific climate sustainability work that Karis is leading, and provide examples of how this infrastructure is helping us embed these different missions across sectors and domains. So to kick it off, just a little background information, and I know there are some Case people at this event and a lot of other Case speakers, so if this is redundant, I apologize, but Case Western Reserve University is located in Cleveland, Ohio, right on the banks of Lake Erie. You can see in the top right photo here, that's our new interdisciplinary science and education building. That is a $300 million building being constructed on our engineering quad. It'll open in fall 2026, and it's organized around thematic clusters. So really focused on breaking down any type of silo and walls between researchers. I think an example of one of the areas of the building that is really exciting to me is there's a pretty expansive robotics area where it's housed, will be part of our Human Fusions Institute, which is dealing with the interface between humans and biological systems and robotic systems to, replace, for example, limbs and things of that nature. Shares a floor with some of our mechanical faculty who's working with biomimetic robots. So really cool collaborative opportunities. And I think you'll see that underscores a lot of this work that we're talking about today as well. For a little bit more background, we have around 12,000 students, pretty evenly split between undergrads and graduate students. And the university does really pride itself on being a community of innovators, knowledge seekers, and groundbreakers. We have some really great resources on campus, such as ThinkBox, which is an open makerspace, and it's the largest open access university makerspace in the world. And Case does now rank as the fastest growing research university in the American Association of Universities. So, really excited about that. And again, I think you'll see this emphasis throughout the presentation. So, pivoting to the Great Lakes Energy Institute, what are we doing? You will see that we are really a platform for faculty, students, and partners that are doing something with an energy implication. So we don't house a lot of research in the institute itself, but we serve to connect people across the university and across the region and across the country and the world on topics that have energy implications. And what that means for how we define areas of focus, it is quite broad. That works really well with a university that's the size of Case. If we were 4 times the size, we might have to narrow this definition a little bit, but this works really well for us. And we play into the strengths of the university, specifically things like advanced and critical materials and electrochemistry. So that is ranging from the lifetime and degradation and performance of materials to end of life characterization, reprocessing of polymers, into electrochemistry, where we have faculty working with, molten salt electrolysis, all the way to thermal runaway of batteries, and again, more lifetime degradation work, some rare earth element recovery, separations, membranes, very, very broad, and it all has an energy implication, and so we will support those faculty. Data governance and stewardship is a big area of focus with our DOE national lab partners. Future power is a bit of a catch-all, but that's where you find, emerging generation technologies, some renewables work, grid research, so, ranging from virtual power plants to demand response management. We have some mathematics faculty, for example, that are interested in those domains. And so future power helps us kind of create some type of umbrella for those topics. Advanced manufacturing, university-wide, this is a huge area of focus, but some of the faculty we support the most are working with things like real-time defect detection in additive manufacturing of metal parts and the implications that has for lifetime and performance. And then 2 areas of focus, which we've been seeing some traction with lately, which I think will continue to grow, are the water research space and then geospatial research. Geospatial really applies to all of these other domains. So we have faculty working on agricultural modeling, watershed modeling, epidemiological approaches to how PV solar installations degrade and perform over time. And then in that water space, again, very broad, but we have faculty working with the biomimetic robots, as I mentioned previously. So some of those are marine biomimetic robots, all the way through sensors for water infrastructure. I mentioned water body modeling and watershed modeling. So very broad. And I'll come back to that when I talk about partnerships in a little bit. But you can see that we have a very collaborative focus and cross-sector focus. So a lot of interdisciplinary teaming it's really key to a lot of what we support. But our kind of clients as an energy institute are, again, pretty much everyone at the university. It's faculty, it's students, and it's our industry and government partners. What that looks like depends on where they are at in their research. So foundational strategy, what is the vision of a research group? Can we help you build a roadmap to grow that research group? What do you want to be doing and what do you need in place to get there? Building teams, making connections with industry. We will support commercialization, obviously, with the tech transfer office at Case if someone's research group is at that stage, but really kind of filling in the cracks wherever someone needs us to provide support. Also, pre-award and post-support, we do a lot of proposal development. That's probably the biggest activity that we're doing at any given time. But then post-award management, do you need staff to support an award once you receive it? That is beyond the scope of what existing research administration is set up to provide. And so we have a number of staff members in the Institute that exist purely to support a specific research group and help grow it. So these are a bit redundant. I won't spend a lot of time on these slides, but again, really meeting faculty wherever they need us to be a tool to help grow the research enterprise and grow their groups. Working with industry and government partners to integrate them with research groups and opportunities as much as possible. We are, a very industry-focused university. We do a lot of federal research. I mentioned our national lab partners previously, but however we, again, can build teams that involve these partners is very important to us. And then students, we have fellowships we run. We try to tie in with other people's student-focused opportunities. Again, it's a university. Students are the central mission of the university. And so how can we support them? How can we help them find opportunities like CISGR and SULI grant opportunities with DOE labs? Where can we help support mentorship with faculty, and where can we develop curriculum to both enrich the students' experience, but then provide skills to the faculty that are needed to grow their research group? So again, this is part of this workforce pipeline, both within the university and then more broadly. And so tying this to energy resiliency and what this means for us right now, there's the more traditional view of sustainability and resiliency, that it's infrastructure, it's technology. I wouldn't say this expanded definition is unique to us. I think a lot of people use this now, but what are the people systems and those pipelines needed to help lock in resilient systems and sustainable systems? And we really believe that the core of that is workforce readiness and this team science approach. Those are the foundations of any initiative that's going to have legs and sustain itself long term. Part of that is, again, understanding the growing demand for technicians, engineers, and entrepreneurs. And where's the fragmentation? Where are the gaps? So fragmented educational pathways and limited experiential learning. CASE as a university is really good at addressing this. So again, the Great Lakes Energy Institute is not the only one addressing this, but this is a key area where we as a university try to provide a lot of opportunity to students and researchers and provide this integrated interdisciplinary ecosystem and make sure that these people are not mutually exclusive. An engineer should have some technical capabilities, and an entrepreneur, to be really powerful, ideally should understand the technology. And these three should be the same person ultimately. And so focusing on interdisciplinary learning and experiential learning. So a core approach being STEM mixed with these opportunities, and then segueing that into workforce development pipelines for our external partners. And so it involves our university, partner universities, mention industry partners a lot, but companies, national labs, anyone that needs students and needs talent, and then regional organizations. And Karis will talk a lot about those networks. But I'll come back to team science and fellowships and how those are really core to what we're doing. But moving on here. So what does the full workforce pipeline look like? We focus a lot on K-12 engagement all the way through PhDs. And the really key thing there is getting them to work with each other. And that's where this team science opportunity comes in. So sometimes we convert a high school student to an undergrad. We convert an undergrad to a master's or a PhD. We want to see that. Sometimes they take their degree and then they go to one of our national lab or industry partners. But there's this moment where we have high schoolers in the same lab as undergrads and grad students, and they can work on a team together. That's really key to us, building this pipeline, locking in these opportunities, and providing that value. And one of the key ways that we are doing that at Institute is what's called the Envoys program. So this is a program that we inherited from another part of the university, but it's a fundamental training and applied research opportunity for high school students to spend the summer as a fully compensated university researcher embedded in a research team. It's split up where the mornings are more fundamental skill building, learning, seminar opportunities. Afternoons, they're embedded in individual research groups. They participate in poster sessions. They present at symposia that we host, and they have their names on publications alongside the PhDs and the faculty. This is a really key way we're trying to convert some of these students and playing the long game for these workforce pipelines. But we see a lot of success here, and this has been a really valuable program, and we're at between 20 to 30 students every summer, which for a group of our size, we really have one program manager running this program. And so it's a really good size, but this is obviously a growth area that we want to make sure remains sustainable. But really quick case study, the SLE Research Center, this is a very, very large research group in our materials science department. They have what is called the MDS Cube Center of Excellence. Roger French, I believe he's at the conference, so you might have talked to him already. You should find him if you haven't. He's really driving team science and this team science concept I'm talking about within the university in a really successful way. This center is structured along cross-cut research thrusts. Teams report out according to their cross-cut and their topic area, not individual PI teams, which has led to a really successful engagement and outcome across the first 3 years. So these numbers at the bottom here are just the first 3 years of this center. And we've been able to engage a really, really broad range of students from across the university and also external researchers working with these students and building relationships and then bringing them out over the summer and coming up with different types of research engagement opportunities. And then finally, I'll just move through curriculum and fellowships really briefly, but this is really the final stage of what we think is really important to create this resilient system. And then ultimately, what Karis will talk about, being able to feed researchers and connections into these climate and sustainable networks. But using applied data science as an example, this is also coming out of the materials department, but it's a cross-listed set of classes ranging from data science fundamentals to topically specific things like geospatial subsurface modeling and then building ontologies and data tooling. But anybody can take these, and so someone from biomedical is usually in a class with someone from materials or someone from macromolecular science or computer science. And then also we've been able to spin this out with partners, so a data science for social impact program, for example. So it's allowed us to have a really nice cross-disciplinary engagement tool for students of all levels. We've launched an energy and entrepreneurship class with the Weatherhead School of Management, which is our business school. Really great way to, again, bring non-engineers into the energy conversation. It's ultimately a communications intensive elective for them. So we're teaching them how to talk about a topic and essentially use pitching as a vehicle to say, here's how you just convince someone of your point or you successfully convey something. They are very interested in sustainability. They want to see that work continue. And so figuring out how that they can choose language and structure those arguments to, again, be resilient through different changing kind of broader policy conversations is really, really critical. And we've seen a lot of success with that class. And then I will hand this over to Karis now to talk about some other curriculum development that's been ongoing.
Awesome. Thank you, Jonathan. I just want to double check on time. Are we still good to
Karis,
move
I
on?
cannot hear you, but maybe that's me.
Can you hear me now? Hello?
We can hear you. Time-wise, we have almost done. So if you can go rather fast.
Can someone in the chat mention if they can hear Karis?
They can hear me. Can you hear me, Jonathan?
Okay. It's just me then.
Okay.
Go for it,
Okay.
Karis.
I'm going to recommend that we move on to the next slide just so I can, because I realize we're at time. And I don't know if Jonathan can hear me to do that or not. But I will just, in the interest of time, as Jonathan mentioned before, when we talk about energy resiliency, we often focus on microgrids and battery storage here at the Great Lakes Energy Institute, but we also know that resiliency is built on people and the systems that connect them. And that's really where things come into play with the Midwest Climate Collaborative, of which Case Western Reserve University and the Great Lakes Energy Institute are members. So the MCC represents a 12-state region. It's a multi-sector network dedicated to a carbon-neutral, climate-resilient, interconnected Midwest. The MCC actually emerged from a glaring need in higher ed to bridge the gap between high-level academic research and boots-on-the-ground climate action, which we achieved by amplifying proven successes, building regional capacity, and fostering cross-sector alignment. One of the ways that we continue to do this as well is, we're working as a vital bridge between academic theory and also the real world workforce reality. So we're ensuring that the innovations happening in our labs are directly translated into the ground game, so to speak, of regional implementation. So this particular collaboration gives our members a competitive edge. It means that you're able to secure early access to joint grant proposals, allowing us to move faster and more cohesively than we could have done alone. And it means having the institutional weight of the MCC behind you through formal letters of support and local initiatives, which oftentimes can be a deciding factor in securing project funding. Another thing is we also, as the MCC, working with the Great Lakes Energy Institute, we're a primary resource for regional data, and we house the Midwest Climate Resource Network. I can share a link to that with this group here. But this is a way to pool resources and create a system that's far more durable than the sum of its parts. And lastly, I just want to plug that the Midwest Climate Summit is really the heartbeat of the collaboration. It's brought in over 500 leaders from every sector across nonprofits, community groups, and government agencies and businesses. It was right here at Case Western Reserve University. And it was an opportunity for our students to really engage, get paired up with a mentor, and really see how the work that they're doing in the classroom has these real world impacts. And so actually my role here at CASE is a direct result of a collaborative fundraising effort between the MCC and GLEI. So again, this is just an example of how networking and building collaborations can really enhance the work that you're currently doing.
Great. Thank you, Karis. And I know we're coming up against time here, and I didn't talk about our fellowships as much, but we do have a program called the Think Energy Fellowship. That has been a really successful way to help seed some student energy startups, primarily focused around sustainability. People want to follow up with me after, I'm happy to talk about that. But I do want to end kind of with basically an ask here for people. This work is really important, and it doesn't sustain itself fully forever. I think we have a very rich support structure right now, but long term, we're looking for opportunities for students. We're looking for ways to tie in these networks with other partners. And so if there is anything of interest that has stuck out to people, I really encourage you to reach out to us because I would love to talk with you about that. And again, on the student fellowship side, which we did end up skipping over a little bit, but would love to connect with some people about that opportunity as well. But I know we are coming up on time here, so I want to stop there and hand it back over to the room.
Thank you, Jonathan. Just aim to keep it with the schedule. Unfortunately, we will skip the questions. But if anybody have questions, I can reach out to Jonathan, or I can give his contact information so you can reach out to him. So we will move to our second talk of the afternoon. From Sarah O'Keefe from the City of Cleveland. She's the director of the city's sustainability efforts.
Hi, good afternoon, everyone. Just give me one moment while I share my screen. Thank you so much. And Alp, are you able to see the screen in your room?
Yes, we can.
And you can hear me fine, it sounds like.
Yes.
Okay. Well, thank you, everybody. I'm sorry I couldn't be there in person, but I'm really honored to have this opportunity to share a bit about engaging community in climate action. All along the learning continuum is the topic of my talk today. And I am going to dive right in. This was a bit of the abstract, so you should be familiar with this, but I just wanted to highlight that what we're going to hit on today is outreach to the general public and teaching sustainability in university courses. These are a couple of the topics. And very specifically, we are going to focus on the city of Cleveland in Cleveland, Ohio, and also the region of the 5-county region, and then the greater Great Lakes. And hang on just a second. Okay. Here we go. Okay, so the presentation flow, just for everybody's reference, we will talk about climate action planning that has occurred between 2023 and 2025. We're currently in the implementation phase of many of our different levels of climate action planning. There are 3 levels that I'm going to talk about in the presentation today. Operations will be very brief. That'll be about the city's operations. That's part of my job as the Director of Sustainability and Climate Justice here at the City of Cleveland. I am a member of the mayor's cabinet and work cross-departmentally on that plan with a number of individuals and stakeholders, where we really embed climate action into the daily operations of the city. We're going to do a lot of focus, you'll see in red here, on the community climate action plan. I'm going to go into a little bit deeper dive on that audience in particular in my presentation and how we've been able to engage community. And then on the regional climate action planning effort. And I'm so glad to be following the Great Lakes Energy Institute team and Midwest Climate Collaborative representation from Karis there, because those are 2 of our really important partners here in Cleveland. I already talked about the different audiences for each three of these levels of planning, but I'm going more detailed into the community level engagement and engagement with higher education institutions, as well as different levels of networks. So this will be a little bit higher level overview of those. We're going to talk a little bit about implementation, what we're doing right now, and how we're tracking progress, and about the Cleveland Climate Action Dashboard. Our areas of outreach and education on climate action planning, as I said, community engagement is really the focus of the talk today. But we have worked with the OECD, for example, and the United Nations Sustainable Development Goals, and elevating those and integrating them into our climate action planning to really have this very local climate action planning effort, have recognized that it has everything we do in climate action has an national or international impact, right? Act locally and impacts are global. I'm going to talk about how we started our journey on decarbonization pathways, talk about the regional climate action plan on which Case Western Reserve University, Cleveland State University, and Kent State University, Cleveland Urban Center for Design, we're key partners in making that regional climate action plan a reality for us here. And then national regional networks, conferences, summits. We also work through course lectures and a Northeast Ohio Youth Climate Summit. So this is a list of the different ways in which we do outreach and education on climate and sustainability. I'm going to show you what the result is of a lot of community engagement and planning, and that learning and education, both from starting from data and research, engaging community, getting prioritization lenses in place, and then having a final plan. This is a picture of the final plan. CAP is short for Climate Action Plan. We have 16 goals, 43 objectives, over 160 actions across these 6 focus areas: built environment, clean energy, clean transportation, nature-based solutions, resilient people, and circular industry. This plan is not something, this was just published in 2025. I'll go into some details about how that came to be. This is not our first climate action plan, but it is a major update. Science-based targets, a focus on decarbonization, but also on resiliency. Our top big 10 highlights here, we've broken it down. You can read through these in the plan, but we're going to focus on a few of them today, mostly on the community and resilient people side of things. So climate change is a crisis that's already harming Cleveland. We don't hear in the Midwest, we don't hear a lot about climate impacts on the Midwest. So that Midwest Climate Summit that we all attended recently here, held here at Case Western Reserve University in Cleveland, Ohio, was such a great opportunity to network and learn peer-to-peer as professionals in higher education institutions, in the city like myself. A number of organizations and businesses attended that. That is key for us to understand exactly how climate is affecting Cleveland and greater Cleveland and the Midwest, so that we can act accordingly and collaborate more effectively. I think another big takeaway here is that all Clevelanders have a role to play in climate action, and you'll see that from our community engagement. We talk a lot about that, but mostly we want to make sure that we are improving the lives of Clevelanders. It's not enough to be science-based targets and do things for science. And the environment, we have to make sure that we link it to the daily lived experiences of humans. Humans are drivers of climate change, and if we don't engage them in realizing that they're also the problem solvers, then we won't get very far. So that's what our plan tries to do, make that human connection. Okay, I'm going to take us back to fall of 2022 when Mayor Bibb was in his first year of his first term here in Cleveland. And I am a brand new person here at the city of Cleveland. I'd been in sustainability and climate justice for a number of years through health systems here in Cleveland. But what we wanted to do was really focus on that quantified science-based decarbonization done in a way that brings equity to our residents, community members, businesses, and organizations. So in the fall of 2022, our goal was to advance climate justice as we achieve net zero carbon emissions. We want to do all of these things: refine existing targets, prioritize the timing of projects, attract that federal funding that was still available in 2022, and we were very successful in doing that, improve community health and equity, make measured progress. And the big theme at the time was Cleveland can't wait. Cleveland's been underinvested in for a number of decades, And you can tell on the resilience side, especially, we had a couple tornadoes in the past couple of years, one that just went through a week and a half ago, and the storm damage was significant. Flooding was significant. So this is an urgent need here in Cleveland. And that was fall of 2022. Fast forward to April of 2023. We held a decarbonization summit, and we wanted it to be very, very technical. But we also wanted to have to answer all these questions. What changes in infrastructure are required, and when? We want to get to 2050 carbon neutrality. How do we backcast to make that happen? I'm not going to go into detail about that decarbonization summit, but if anybody's interested, I can send you the decarbonization pathways framework that came out of that. One key thing there was we wanted it to be very technical, but we also wanted there to be a public education component. So in the morning this is a one-day summit. In the morning, we had everybody can come in and learn about climate action, the planning, what we're doing, what we're talking about. And then in the afternoon, we had very technical tracks that people signed up for. We invited specific people to come. Great Lakes Energy Institute was one of those stakeholders, for example. And then we also had a Climate 101 public, please sign up for this, learn about climate change and how it's impacting you. So that was a good outreach. And all of the things that came out of that summit in April 2023 went into our regional climate action plan, which I will talk about towards the end of my presentation. But it kind of outlines how long it takes to engage and to educate for planning to come to fruition. We could have just done it on our own and not involved anybody, but nobody would have bought in, nobody would have supported it, given it the support it needed to pass a number of governmental policy groups here in the region. So this is important that we engage the community on a regular basis. And then we make sure we're bringing people along with us and getting input on what's important. Our own climate action plan update, this is for the city of Cleveland in particular. So this started, and I'm guessing it's probably hard to see in the room, but you can see an arrow across the middle here. And the timeline ranges from summer of 2023, just after we had that decarbonization summit. We started updating the data, the things that we did in-house or with some consultants as we did data and research, right? And then we had in the fall of 2023, after we collected data, we engaged the community in what's called a climate risk vulnerability assessment, fall 23. In the spring of 24, we had CAP working groups. Those are working groups of subject matter experts from across the city who work in built environment, clean energy, resilient people, nature-based solutions. And we said, hey, we have a climate action plan from 2018. We want to update it. We just had this decarbonization summit. Let's bring it all in. And what are your suggestions for how to do that? We worked intensely over the summer with those groups. And then in August, we came back to the public and we engaged them in talking about the climate action plan so far. Like, what did we have so far? What are you interested in? We have a risk vulnerability assessment. We use that to prioritize our update to the climate action plan. And then what do you think, public? So we had a number of, that's our public engagement in August 24, and in September of 2024, we had another round of educational workshops, as well as in October of 2024. And then towards the end, we had a stakeholder prioritization workshop. We had our December 2024 public comment, so people could comment. And then in January and April, we took all of the feedback and incorporated it into our climate action plan. I think it's important to note that there are different ways to engage and different times that we engaged. There were 4 major periods of community engagement. 1,000 plus Clevelanders were engaged, including surveys, 109 in-person attendees and community conversations. And it's important to note that attendees were diverse in demographics and income and reflected the community about which this plan was being made and for which this plan has been made to calculate benefits such as jobs, healthier air, cleaner energy, and so on. Here are a couple pictures of our community engagement. We engaged, as you can kind of tell from the photos, all types of people, all ages, across different community organizations. Kind of a little bit more in the detail on community engagement here. Here was our approach. Meaningfully engage citywide stakeholders in developing those updated goals. So we had the research, we had our greenhouse gas inventory, we came together and we worked with community-based organizations, residents, and city workers with an equity focus on communities that were most impacted by climate change. So when we went out into the community for a workshop, we went to the very communities that our climate risk vulnerability assessment said were the most at risk. And that's where we held our workshop. So at the results of our community engagement, as I already mentioned, 1,000+ community members were engaged. I'm going to go into a couple of the steps that a little bit more detail in July and August of 2024. After we had some data, we put out this community climate action survey. And the distributions were through website and newsletter and social media, as you might imagine. But we also asked our partners, our community partners, to send it out to their networks on their listservs. We asked what were called our advisory committee members, so those subject matter experts that work in those 6 different areas: built environment, transportation, resilience, clean energy, nature-based solutions, and said, hey, can you reach out and get this survey answered? We had 368 verified responses. Issuing a survey through SurveyMonkey or something similar is very challenging these days to get away from bots, but we actually verified. So we had over 1,000 responses, 368 were verified. And we conducted extensive outreach. As I already mentioned, we used a data-driven process to select a location for our in-person engagement that centered around our climate risk vulnerability assessment. And attendees were diverse in demographics and income, as I mentioned. Key themes and takeaways from our engagement events were that residents were most concerned about a very real impact of climate change here in Northeast Ohio: storm damage. We have more intense storms and they damage things, and then people are even more at risk because they have to pay for repairs. And flooding is another one. Clean air, clean land, clean water, trees and green space are priorities. And then the need for financial resources to actually support climate action. That's what came out of those individual in-person events. I think it's important to acknowledge in this kind of community engagement who actually does the work. I'm presenting to you as the Director for Sustainability and Climate Justice, but I don't always do all of the work, right? I have a very robust team, thank goodness, and a lot of collaborators from across the city. In particular, Cleveland of City staff, City of Cleveland staff, Tim Kovach, our decarbonization strategist. We had a nature-based solutions sustainability manager named Anna Zaremba at the time, Felina Selden, our current manager of education and outreach, and supported by other staff, really boots on the ground doing this work. We also had a consultant who was a woman-owned business. Hang on just a second, sorry. You can tell that I'm really committed to saving energy. So we had a small woman-owned business as our consultant and supported by subcontractors. This is an example of our specific community roundtable in August through September. I just wanted to walk through the program so you can really see what we mean by engaging with community. Our roundtables started out with 30 minutes for a meet and greet over a meal or refreshments. For those of you not familiar with the city of Cleveland, Ohio, we have a high population of vulnerable residents who are lower income and have very little time. We wanted to have authentic engagement from those residents. So how could we make it an accessible event? We provided transportation, we provided food, and at times, if necessary, provided childcare. We worked with community partners to make sure that that event made sense for that community. And so we started off with a meet and greet and just very casual, informal meeting over a meal and refreshments. We talked about the impact of climate change on a neighborhood. Then we talked about the neighborhood aspirations. What do you want your neighborhood to look like was one of the questions. We explained the discussion of the different focus areas. We talked about 5 here because those are the 5 technical focus areas we worked on. Resilient people is the 6th. And then we had a discussion of barriers and blind spots and solutions. And then the roundtables ended with a 2-minute exit survey, both paper and electronic options. Here are some examples of some pictures of those interactive. You can see we're sitting down at a table here at a local restaurant, for example, and in this one here in the top right, this is at a community gym. You can see in our rec center right here. This is an example of the different neighborhoods. We had different community partners from a larger organization called Ohio Environmental Council and Young Latino Network to a very small, see you at the top, homegrown 3-person scrappy team that helped us set up these different community engagements. And then you can see that depending on each location and how it was organized, different people needed or wanted different things, different kinds of support. We started out with a meal in a couple places, but at one, we had our engagement at a Save-A-Lot because that's where the community went to get news and to understand. Save-A-Lot is a discount grocery store for those of you who are not familiar. And at that location, we gave everybody a $20 Save-A-Lot gift card. These are some actual questions that we asked. What is your aspiration for your community? What focus area, after we talked a little bit about them, do you want to discuss? So we had some, you can even see on the right here, we had some dot voting picture up here that was in Spanish. So we had interpreters for Young Latinos Network for one of our sessions. And on the left, this is the parking lot of Save-A-Lot in the St. Clair Superior neighborhood. And then we really went into solutions. How could the city of Cleveland address the concerns that have been brought up today? So those are examples. Here's an example of one of the questions that came out and was very significant for us to help us understand what was still needed in climate action planning from the perspective of a resident. One of the things you can see here, what is a resource or type of support city could provide to help you take action about climate change? The top response was being informed and educated, which is very appropriate for today's topic. So how did we do that? The next phase of our community engagement was really impacted by that feedback. So instead of doing more input gathering from community members, we did what are called educational workshops. So the goal of our educational workshops were to provide an overview of climate change in Cleveland and the climate action plan. So it was a little bit more formal. It was more educational in focus. Our community roundtables were definitely like having a conversation, getting feedback in an informal way. But this was more come learn about climate action. So we joined some community events like Fresh Fest. That's a big event here in Cleveland at a local urban farm called Red All Green Partnership. We engaged people there. We did a nature-based solutions tour, totally different. It was you get on a bus and you go to different examples of where nature-based solutions or natural systems like green infrastructure for storm drainage and stormwater management, tree plantings. So that was that particular education workshop. And then we had a food mobility and climate justice workshop at a recreation center. And then finally, we had a youth education session. It was important. We knew from our data gathering that we didn't have a lot of input from youth and that youth are going to be some of the most impacted Clevelanders going forward from climate action plan, from climate impacts. So that was at our Cleveland Public Library, accessible by transit, right downtown. It was during the afternoon, so kids were not out at night. Following those educational workshops, that helped us also get some feedback and then also educate at the same time. We distributed call to action forms. On the left, you'll see an image of a postcard that was left at other community events that we weren't hosting. So we have a calendar of events, community events, where we would go and maybe table or ask somebody from the city of Cleveland to distribute these cards. And it was really a call to action for somebody to say, okay, this is climate action. This is what our plan is about. You can go to the QR code, learn a little bit more, and submit resident feedback here through this online form. But on the back, there was actually a place where you could just write your answers. We had pens, we had postcards, and then we collected them. Responses from both of these methods and all of our workshops and community roundtables were collected and considered in the prioritization of actions in the final plan. We have 162 actions. Where do we start? So we have flags on some actions that are community priorities. Those community priority flags come directly from all of this community engagement. Kind of more specifically, how each stage of the community feedback was used. We had 4 different stages for a reason. Our survey responses helped inform the development of a framework to evaluate our actions. So we had a bunch of actions, then we had to evaluate them and see about that prioritization. Community roundtable feedback incorporated in other ways, such as updating goals and actions to incorporate their feedback, right? And also in the evaluation of actions. The more support that from public engagement that something got, the more points that action received. So if we heard about an action more, that is a more community priority tag. Educational sessions, the feedback there really informed, how much we had to explain, how much was interesting. It really informed our marketing and implementation of the CAP going forward. It informed how we set up the final plan that was published. It informed our decision to have an interactive dashboard that I'll show you at the end of this presentation. And then in November, December of the public comment period, we had that feedback incorporated into the updates. And then finally, in January, March is when we finalized that incorporation of that feedback. And then April 22nd, 2025, on Earth Day, we launched that final printed plan. I'm just going to hold up to the camera. Hang on just a second. We had very few of this printed, bound, 200-some page, beautiful report available. The full PDF is on our website. And then we had this. It's a climate snapshot. You unfold it, you get the highlights from the plan, and then we have a QR code on the back that goes to our website. So I think it's important to have a few different ways to give feedback and have that final plan. We also had a community toolkit also available on our website, and we can email it, and we've shared it with a couple of community members. This is basically a how-to. You have our plan, but how do I talk about, as a community member, how do I talk about climate? How do I talk about climate action? What can I do? So that's also a resource. We have many different ways based on the feedback that we received, many different ways that the plan came together, same actions, same goals, but different ways to communicate about it. And I wanted to do a quick time check. I believe that I had until the top of the hour out, and I think I'm out of time. Or do I have a couple of minutes?
It is, according to schedule, we had you, the next speaker was going to be 1:55 our time.
Oh, okay.
So, sorry to interrupt.
No, that's fine. I'm going to send these slides to you. I just wanted to have one last thing. There are many levels of climate action that I talked about that we engaged in. And this team I already mentioned, this is the Climate Action Planning Grant. And I just wanted to get to this one last thing. And thank you for all of the different opportunities from today to visiting with different higher education institutions to collaborate. And I think it's really important to have things like our meeting today to be able to share this information. We also have regional, national, international networks that we connect with. And then finally, we have feedback loops in our working group. We have community events, and then we have our interactive climate dashboard. I hope that at one point you're able to check this out. You can go to the City of Cleveland Sustainability website, and you can find and click through our actual climate action plan. So here is if you want to just take a picture if you're in the room, here's my name, our email address to get in hold of us, and then our website.
Thank you, Sarah. And to keep in time, I will please reach out to the email that you saw from Sarah, as well as you can reach out to me if you have any questions for Sarah. To try to stay with the schedule, we're going to go to the next talk from Doug Mazeffa from the Lincoln Electric Company.
Hey everyone, just bear with me here while I get my slides going. So, well, first off, thank you all for allowing me to present today. Once again, I'm Doug Mazeffa. I'm the Sustainability Director for Lincoln Electric. I've been in sustainability for, gosh, about 20 years now. Only been with Lincoln for a couple of years, but backgrounds in sort of life cycle assessment and environmental footprinting. But like a lot of sustainability folks, you sort of touch a little bit of everything. So today I'm going to be focusing on sustainability and supply chain. And first off, just to give you a feel for who Lincoln Electric is, don't worry, not a advertisement. We're not a utility company, despite the name. We do get that a lot. But we are the largest welding equipment and welding consumable or wire company in the world, and also a very large kind of robotics and automation manufacturer. So we have a bit of a unique business, tens of thousands of suppliers globally. We sell in 160 countries. And, we have customers that are also suppliers or sometimes competitors that are customers. So we really touch a lot of different things, just very much behind the scenes. And in fact, one of our more recent products has been battery electric vehicle chargers. That's been something we've just started doing in the past few years. So we're dabbling in a lot of different areas. So before I get into some of the supply chain, I took this from a book cited at the bottom left, but this really resonated with me as someone who's been doing sustainability in the US for a while. But, what I sort of witnessed in my career is sustainability going from sort of this do less bad compliance, reputational sort of thing to, maybe 10 or 15 years ago, you really started seeing major companies have dedicated green brands, or companies like Patagonia or Seventh Generation that maybe weren't the biggest in the world, but really had a dedicated sustainability message, to 2018, 2019, what the authors here call the purpose-driven era. This was sort of the rise of ESG, and really for the first time, you were seeing major companies integrating sustainability into their culture. In some cases, even merging annual reports with sustainability reports. Wasn't maybe necessarily the norm, but it also wasn't that uncommon. The fourth bucket here was sort of my own addition, where, there's now sort of been a lot of uncertainty injected into sustainability, especially in regards to a lot of the different regulations and whatnot. And this is especially true if you're a global organization. But what I want to highlight with this is it's become more important than ever to have good communication with your supply chain, with your customers, because sustainability is just such an inherently broad topic, and a lot of the requests are getting much more specific and tactical. So it's really critical to be able to ensure that you're sort of speaking the same language, even on something as seemingly as straightforward as like a product carbon footprint. There can be, as I'll show you, about a dozen different ways someone could get to a carbon footprint of a product that are all technically accurate, but could be relevant in different markets, different industries, or in some cases, be much sort of less stringent than others that could be much more formal. So it's just critical to be able to sort of know your audience. So broadly speaking, from sustainability trends, we've actually seen demand continue to increase. It's been pretty steadily increasing. I mean, most of my career at this point, but even I've been a bit surprised, even over the past 18 months, we're not talking about incremental increases in demand. I'm talking like 2x, 3x. I mean, as I sit here right now, we're over double the number of requests we've gotten for customer sustainability we had this time last year. And frankly, it shows no sign of slowing down. And we're actually seeing more and more frequently customers where some sort of sustainability deliverable, generally something like a life cycle assessment or environmental product declaration, so sort of a product environmental footprint document, that these sorts of deliverables are actually needed to even bid on a project. And, they're more common maybe in Europe, but Asia, even North America. I mean, it's actually a pretty global trend that we're seeing, although Europe is certainly, still the, I would say, undisputed leader in this area. But, we're getting to the point where the questions are getting much more specific. This isn't a questionnaire that is sent out, once a year from a customer where it's asking for, do you have a policy for XYZ? If so, please attach said policy. And then it kind of goes into a file somewhere. Really, the way things are moving are specific products. People want to understand the impact of what they're procuring from you. And therefore, companies like mine need to go back to our suppliers and say, hey, we need to understand the impacts of like the metals we're using so we can figure out the impact of our finished product, which then goes to our end customer. So that, once again, dialogue is really continuing to be very, very critical. And the questionnaires, they haven't really gone away. There's still a lot of third-party platforms that sort of give some sort of assessment of a company's sustainability program. But I would say very comfortably that even a business like ours, which is more behind the scenes, we do sell to consumers, but it's not the focus of our business. I don't think if you list most impactful or obvious activities, welding would be, super high up the list. But I mean, I can't go a day without customers, reaching out to us and saying, hey, we need your impact information. And that's outpacing these more traditional questionnaires, which I personally find a kind of a combination of exciting and also a little bit terrifying at times. And why we're starting to see this demand, some of it is definitely regulatory pressure. There's no doubt about it. But a lot of organizations, they have 2030 goals, or they've made commitments in the future around scopes 1, 2, and 3 reduction. And for them to meet their goals, they need to sort of go up to their suppliers, who then in turn keep kind of going further and further back the supply chain. So it's been interesting that, 2025, 2026, there seemed to be a bit of a tipping point in regards to a lot of the sort of product carbon becoming a very front of mind sort of request. The challenge with it is, even if we're just talking about, products and carbon footprint, it's still very, very complex. And there's not just sort of one way to do the assessment. And so there can be a fair amount of confusion even when you're seeking information. And I'll give some specific examples of this in a bit. So now extending this a bit more to supply chain, what's been really fascinating. So for folks, in the room or who work for global organizations, last year, Europe did as part of their omnibus, there was a 2-year stop the clock on a few European rules, and also the scope of some of these rules were changed. So specifically, I'm speaking to CSDDD, the Corporate Sustainability Due Diligence Directive, and CSRD, the Corporate Sustainability Reporting Directive. I think I got that right. A lot of acronyms. So with that stop the clock and with some of the criteria of who's in scope, like we're a US company, but we do a lot of business in Europe. And so we are part of, I believe it's wave 2 now with some of these reporting structures. But CSDDD, the due diligence directive, this was one where we actually got pulled out of scope as part of the omnibus. And this is one we were watching very closely. And I remember being in a meeting with leadership when we realized we were now out of scope with the omnibus. And, the folks were like, oh, okay, this is one less thing we have to worry about. And I remember being sort of the bearer of bad news, where it's like, well, yes, we don't need to do this disclosure, to the government or have this certain thing published publicly, but understand all of our big customers still have to do this. And this is about supply chain due diligence, and we're part of their supply chain. So in effect, we still have to do a lot of the same activities, because they're just going to turn around and look at us, and we're going to have to do the same thing to our suppliers. So really sustainability has pivoted a bit where, I came from a world of sort of voluntary standards and differentiation for points in a green building system or a variety of sort of indirect value adds. Now we're really seeing this becoming, a hard requirement for businesses to the point where we have received requests for proposals where they will actually say we have a number for like a carbon footprint, and if you can't beat that number, and we're not going to tell you what that number is, we're not going to spec your product. So there's a lot of very deliberate steps that have been occurring. And so for folks that maybe aren't as familiar with sort of what due diligence and sort of how it impacts sustainability or regulations, I would say due diligence is most common, most relevant in some of the social sustainability areas. So you see it a lot with conflict minerals, forced labor, child labor, human rights, things of that nature. And the way I sort of liken it is, as I said, 5, 10, 15 years ago, it was questionnaire. You have policies that cover these topics. Okay, attach your policy. We're good to go. With these due diligence rules, what it's forcing companies to do, and I think this is largely a very good thing, is okay, you have the policy, but what's your process to make sure it's in effect? And are you auditing it? And what happens if you find something that is bad? What if there's a noncompliance or a vendor is breaching some sort of human right? And so really now it's less about sort of aspiration and having this piece of paper. It's much more tactical on specific issues. And certainly there's some growing pains just due to the complexity of supply chains, but I can't stress enough, like this is really leading to a lot of, I think, positive change and accountability throughout the supply chains. But with due diligence, with carbon border adjustment mechanism, life cycle assessment, pick your sort of acronym. Sustainability is very data hungry. And as I keep saying here, there's not necessarily one way to do a carbon footprint. So or any sort of qualitative assessment. There's some inherent subjectivity to a lot of sustainability. So being able to trust your data, one, within your own organization, but also your suppliers and customers and other stakeholders is so, so critical. And it might sound trivial, like, well, of course that is important. But you're talking about, I mean, just to give some context, when we did our Scope 3 emissions for purchase goods, so everything our organization purchased last year, we're talking about hundreds of thousands of line items that we have to account for. And so you really need to make sure that systems are communicating, that you can get the information from your suppliers. And if you have 20,000 suppliers, you have to find a way to do that in a relatively painless fashion for them, or they're probably not going to respond. But once again, the real crazy shift has been, it used to be if a law didn't directly apply to an organization, it was sort of like, okay, you don't have to worry about it, like with the CSDDD. But with global organizations, it's sort of like what happened with Proposition 65 in California. You don't want to do something separate just for California, so you tend to do the same activity everywhere, or at least domestically, to be able to make it more efficient for the business. And so I think we're really going to see something similar happen with a lot of these different due diligence and sort of carbon rules that are being passed. So obviously there's some challenges, supply chain size, complexity. I can't tell you how often, and this could be customers or suppliers. Some are very savvy. We could reach out to some of our, metals manufacturers. You say, hey, I need your XYZ data. They have it. Great. We're good to go. But when you have 15, 20,000 suppliers, there's going to be some that have never even heard about what you're asking for, who might operate in a part of the world that it's not directly impacted by a certain. So there's really become sort of an education moment. And I think a lot of the better external platforms that sort of collect this data for organizations are starting to really lean into this education, making sure that folks understand, what's being asked of them and finding ways to make it more feasible. Because even life cycle assessment, which is my background, when I first started my career 20 years ago, these were things that were very expensive and slow, and very few companies could really afford, frankly. Now they're becoming increasingly common and they're infinitely more scalable. It's a very small fraction of the cost of what they used to be. And so I think we're going to continue to see that sort of improvement, even if sometimes, the rules being set first and then the data is sort of catching up to some extent. There is still a lot of fragmentation by geography, but also by sector. What's been fascinating, given how broad our sort of customer base is and our supply chain is, that certain requests will come in and I can immediately tell you what industry it's from, just not even looking at the company name. It's just like, oh, wow, automotive. Like automotive requests have a very specific, detailed look. They're much more consistent across like the automotive sector. Same with maybe energy. Then there's others that are maybe a bit newer to some of these different sustainability rules or have been sort of less impacted historically. So it's really been interesting to see sort of all the different journeys that organizations are having and having to work with them to sort of hit these different shared goals. And although I mentioned external platforms, which are a great way of doing things, there's not one platform that does every sort of regulation or every sort of attribute for a product or a corporation or different rules. And it's probably unrealistic for me to ever think there could be. So, they're powerful, but you typically have to lean on a few different platforms and make sure that those platforms can integrate within your own IT systems and where your data is coming from. And so then there needs to be sort of management as a part of this. And you can do things internally, sort of homegrown questionnaires and collect the data, but then you're basically staffing a number of folks full time whose sole responsibility would be doing supply chain sustainability, which there are those roles. It's absolutely happening. And with all things sustainability, there's always trade-offs. So it's sort of like what's better. If something's better in a carbon footprint but worse in water, you sort of have to make these difficult judgment calls. And I know we're short on time, so I won't really spend much time with this. But each column on this chart is a different type of packaging, and there's sort of a relative scaling. And green dot is obviously better than yellow or red. And when I ask folks, well, which packaging is the best one? And people generally pick the first and the fourth columns. But when you do something like that in sustainability, you're effectively saying, okay, the 6 indicators, human health, ecosystem damage, climate change, so on and so forth, we're effectively saying those are equal. That's subjective. I don't know. We're also saying they have the same degrees of certainty. That they certainly don't. Some of things like human health are tremendously complicated, where you need orders of magnitude of differentiation before you have a statistical significance. Others, like climate change, it's a much more narrow band, maybe 10, 20% or so uncertainty. So, and then there's things outside of the scope of this, cost, availability, performance. This specific example is for a food packaging company. I think went bankrupt 20 years ago. I've been using it that long. But what's interesting is if you do that averaging exercise, you would pick the first column, which is actually styrofoam. Very resource efficient, but what's the biggest issue packaging is facing with all the laws and extended producer responsibility? It's waste. That would be a catastrophic choice to make if you were a food packaging company. So there's kind of a story behind the numbers that you sort of need to become comfortable sort of walking through. And this just illustrates, this is actually about from a year and a half ago. I like this graph because it does a good job showing that even the same topic, modern slavery, child labor, conflict minerals, there's variations of the same rules geographically, and they're not always directly interchangeable. In fact, I would say they're seldom interchangeable. So if you're with a global organization, it's important to understand this nuance, and then there's sort of the education around the supply chain that has to happen on occasion. And even product carbon. So this is if a customer comes in and says, hey, I need a carbon footprint for XYZ product, probably 9 times out of 10, that's sort of how the request comes in. The first thing we have to do is say, okay, but what are you using it for? Is this sort of an informal thing? Is it for your scope 3 emissions? Are you doing a life cycle assessment or an environmental product declaration? Because the whatever 10 or 12 things on this list, I've been asked for one of these, or at least one of these, from a product just so far this year. And all of these can generate a carbon footprint. So they're all technically a carbon footprint, but they would not generate anywhere near the same value if you were to do these in practice. And it's not that there's one that's better than another. It's just different ways of looking at, where the scope is, what you count, what you don't, how much peer review does it go through, how specific do the rule sets get, things like that. So this is where it's really critical that when you work with your suppliers and your customers, that you're all sort of in alignment, that, what standards do you need the data to? Because otherwise you're giving them apples and oranges. And when you start talking about big supply chains, it's very difficult to manage. And so last sort of slide here. So how do you sort of manage this? And the truth is there's no easy answer, but I keep saying it, clear communication and education, if necessary, is really what I found is just the best way of doing things. And if you're in a sustainability role, you actually add a lot of value to sort of the sales process or the raw material procurement process. So it's really kind of been an enabler, I think, in a lot of organizations I've had the fortune of working for. And yeah, it's just you need to make sure that they're giving you something you can actually use, because sometimes you'll get a new innovative product which says, oh, it's carbon neutral or whatever. And it's like, well, maybe, but can you show me how you got there? What standards was it vetted? Was it peer reviewed? Is it, and that's where it's like, oh, okay, they picked something that's all well and good, but I can't use that number as is. And that's where it starts to get really tricky. Something that also sounds very obvious, but I've run into this in my career, is having a centralized procurement group. I think for a lot of organizations, if you keep your procurement at like a site level where each facility can kind of get what they want as long as it meets some sort of universal technical spec, I do think there's sort of a ceiling in terms of size those companies can get. But in terms of the data that is sort of being necessary now from a global compliance standpoint, sustainability, if you have 70 different plants that are all sort of going from different vendors, it's a nightmare. You would absolutely, like, you need one source of truth. And if you're not on the same system, you're really going to have your work cut out for you. So I'm not saying it's impossible. I'm sure there's folks that can manage this relatively effectively, but it makes it infinitely more complicated when you're having to go to different systems or different people for the same sorts of information, because a lot of these requests, it could be product level, but it also could be across your entire enterprise. The external platforms can be, a great way to get a head start. Obviously, there's a cost associated with that. I'm not going to say any, names of any of them. I certainly have my thoughts on a few, but, this is a great way to, to shortcut a few years, albeit at a cost. As I said before, there's not one vendor that can handle all aspects of sustainability and supply chain in a seamless way. They're generally better in certain areas than others. Some are great in the social areas. Some are great environmental. Some focus on conflict minerals, and that's okay. It's just really engaging your IT group to make sure that you can leverage, the information that you're going to be getting from those platforms. And last one, and this one also sounds kind of silly, but you would be surprised how many organizations out there will have a great sort of policy for like a supplier code of conduct, and have maybe a great process about how they're auditing. But if they won't have any sort of remediation steps, so if they find a nonconformance or if there's an issue, there's no corrective action plan. There's sort of, you just don't know what happens. And it's not that you have to immediately kick the supplier to the curb, but this is something, as these due diligence rules continue to become more relevant, it's going to force this to be more transparent across the board, because you can't just have a black box with these different roles. So with that, my contact information, please feel free to reach out. I'm on LinkedIn and all the other fun sites. And I don't know how we're doing on time, but happy to answer any questions if I didn't run over. And thank you again, all.
Thank you, Doug. You didn't go over, but we were kind of late. So if you don't mind, you share your information there. And also the people can reach out to the organizers of this symposium, and we can reach out to Doug for you as well. And we need to move to our next speaker because our symposium is 8 minutes behind. Thank you, Doug, for the presentation again. And we will go to our next speaker, Krista Bailey from Penn State University.
Hello, everybody. Great to be here with you all today. I'm sorry I couldn't be there in person, but we'll make this fun regardless. So I am here to talk about incorporating sustainability competencies into curriculum. So I suspect if you are here and listening, it's because you're developing maybe a sustainability degree or a certificate, maybe a school, or you're just looking at a class that you want to put some sustainability into because, as we've heard today, that's important to know. But whatever the scale and scope of your interest, I'm going to provide an overview of what to include and approaches to including sustainability into curriculum. But a spoiler, there's no best way, though there are frameworks and tools that can and should be readily adaptable, because the sustainability education field has, I think I can say, officially been established. So my goal here is to not overwhelm you with a lot of information, but to help you feel certain that what you're creating and incorporating is solid and well-grounded. And to help you adopt this shared set of sustainability learning competencies and outcomes, and of course, aligning that with your program and institutional goals. So let's go, because to develop strong programs that will help all of our students learn about and be able to do sustainability, we need a shared framework within which to build our courses and programs. To explain it, I'm going to use a 30-plus-year-old sustainability framework from The Natural Step, which was founded by a Swedish cancer cell scientist named Karl Heinrich Robert. And it's been used in large corporations and municipalities and has a strong contingent still in Canada and many other places. But it's the ABCDs, which begin with awareness about the issue and the opportunity of sustainability, using that to define what success is, understanding the baseline starting point, then looking at creative solutions that help achieve that vision, and then, of course, getting down to action. So this isn't a revolutionary approach. In fact, many of us use this if we're pursuing a degree or planning a vacation. So I'll use it to map us towards our vision of sustainability in our curriculum and courses. So using those ABCDs, got a few key questions to answer. What's going on? Where do we go from here? What should be included if we're going to teach sustainability? And how can we infuse sustainability into curriculum or a course? And how and why should we align our work with our institution and with each other as educators? And that last one's a really big question, and I'm not going to answer it today, but we are going to share some creative solutions and action steps to hopefully help you move in that direction. Because teaching about climate change and the UN Sustainable Development Goals and all the opportunities to address related opportunities can be really overwhelming for faculty and for students. So we're going to try to hone in on a shared set of sustainability competencies and learning outcomes that align with your institution's goals, and hopefully provide an overview of a few articles and resources that you can continue to refer to beyond this. So let's dive in, beginning with awareness. So understanding the issues and the opportunities and identifying a shared definition. And as educators, we know, or should know, that we should also explore the source of the information that we're learning. So in this case, who am I to raise your awareness about sustainability curriculum and best practices? And what are my motivations and goals? And how does my experience influence the message? Plus, it gives me a chance to further introduce myself a bit. So, I'm a daughter. I was raised in a lower middle class, Midwestern, diversified suburbia. So that's me in the upper left corner. Below that, I'm a sister, I'm a mother, I'm a partner. They're my support system. That's who I support first. Moving across the screen there, I'm an instructor, I'm a mentor. That's a group of my student interns that were undergraduates, graduate students, international students, first generation students, and traditional students. I've also been a spokesperson for sustainability on local TV programs and events and working in local government. And my hobbies definitely influence my message and who I am and where I'm coming from. I'm a rower that also keeps me outdoors, but also thinking about sustainability, especially clean water and equitable access. I'm a gardener, so I think a lot about soil and climate and health. And I'm an avid bicyclist, so I think a lot about air quality, conservation issues, urban planning, and transit infrastructure. So that's who you're hearing from today. And my work is really steeped in reporting and data experience that I use to help improve and communicate about higher ed sustainability. I use my teaching experience, which I've infused with experiential learning at all levels, to train and support faculty at Penn State to do the same with a faculty program building experiential learning skills. I've worked with the International Alliance of Societies for a Sustainable Future to release a report on principles and best practices, which were curated from universities around the world. And at Penn State, I've collaborated with our education team to develop sustainability learning outcomes in support of a new sustainability attribute that was just passed by our faculty senate. Yay. Now we have a gateway to bring together all those courses and experiences for our students. Our own sustainability learning outcomes looked to some of the leading competencies that have been identified in our field. So let's get some awareness about those. This is just a kind of a generalized timeline for the development of sustainability competencies as widely accepted by the academic community. And by 2021, Redmond and Week had reviewed not only these authors on the screen, but 110 other developed frameworks that led to a set of meta competencies. And they highlighted intrapersonal implementation, integration, and define futures, values, and strategic thinking competencies as, quote, critical for change that disrupts the status quo and is thus more transformative. The competencies focus on planning, implementation, and having the inter and intrapersonal skills to integrate transdisciplinary content into action. No small feat. That's a lot of things to weave together. Now, the first program I worked with, I'm sharing this somewhat embarrassingly, these were our learning outcomes. Yes, we had 10, for a lot of them, and we had no guide at that time. This is before those publications came out, but happily looking back at these, I see that the first few are focused on systems thinking. The next couple and the last are about implementation, using tools and applying concepts and sustainable solutions. There are a few interpersonal skills, such as collaboration, leadership, persuasion skills, and number 7 is foster strategic thinking. And finally, and very importantly, number 8 focuses on ethics, which is a lot. Right. And it's kind of a mess, I admit. And we didn't really have any guidance, except that what we could draw from the issues and approaches that we were seeing taking place in the communities and businesses in our area. And to be honest, they were finalized by my mentor, who is a tenured sociology professor with a real passion for sustainability. That said, they align pretty well with the competencies that we have today. And when we were developing these, we really started with those end goals. What our students needed to know was how to share knowledge and inspire action, and to help students prepare for a changing workplace that has sustainability and climate way more central than ever before. So now you have an awareness of who I am, who's talking to you, what we're talking about, what we're facing, and where we want to go. So let's try to answer the question, what do we include in sustainability education? And we'll look at where we are now with curriculum, competencies, and best practices. These are the competencies outlined by Redmond and Week in 2021, and they've remained pretty stable over the last few years. The goals are for students to be able to analyze complex systems, anticipate changes in those systems, apply principles and morals when making decisions, construct viable plans, collaborate with diverse people, put ideas into action, and utilize collective problem-solving processes, and importantly, including sort of resilience-oriented self-care as key competencies for the next generation of sustainability professionals. It is important to ask how those serve our university's goals, mission, and vision, and values. For our programs to be supported by our universities, they need to support the mission, and administration needs to know how they support the university's mission. So at Penn State Sustainability, we are supportive of Penn State's purpose by helping to build a resilient Pennsylvania, by working with our communities and stewarding our landscapes. We are focused on key priorities, including energy and climate, sustainable buildings, transportation, waste reduction, food security and equity, landscapes, water, biodiversity. We are adapting to changing needs, particularly by fostering interdisciplinary education and research. And we're leveraging what we know to pursue funding and partnership opportunities and drive meaningful outcomes. Your opportunity is to be able to map your program to your institution goals or risk being ignored or unfunded. It's happened before. It might be happening now. Don't let it happen to you. Try to make a good case for what you're doing. It shouldn't be too terribly hard. And luckily, we have some great frameworks to use that are very useful, but it also helps to know what works best and where and how. There is a session coming up shortly after that will talk a little bit more about this report, or you can grab it by scanning the QR code. But thankfully, to address the what, where, and how to do sustainability education, we are standing on the shoulders of giants. There is a global movement in this area, and not only do we have competencies, we have global best practices that include teaching systems thinking to inspire change on multiple levels, infusing sustainability across the curriculum, and engaging students' head, hands, and heart. These are practices that are in play at universities around the world. So we've got some awareness about what we're talking about, what we're facing, where we want to go. Got some baseline understanding of the competencies and some best practices. So now it's time to do something with all of that by thinking up some creative solutions. Now we don't have the time or space to have a nice interactive conversation, although that would be delightful. Instead, I'm going to share a few creative solutions that I hope will inspire and inform your own work in this area. They came from a review that my colleagues at Penn State Sustainability did of 158 learning objectives from across the United States. They've chosen from institutions that were public, private, research, liberal arts. They were different ACerS stars ratings, different population sizes, all kinds of measures. Tried to get a diverse collection. So here are some of the solutions that our peer organizations have come up with. Elmhurst University in Illinois has a learning outcome for interpersonal literacy, which aims for students to be able to communicate complex environmental information to both technical and non-technical audiences. This could be infused into any number of courses. I'm thinking of communication courses, but also some engineering courses. San Diego Mesa College addresses temporal thinking by preparing students to be able to analyze practical and theoretical issues related to sustainability from current and historical perspectives. Again, A lot of history in there, could be a great part of a history class, but why couldn't history also be part of any number of other courses? For ethical literacy, Santa Clara University's learning outcome is for students to be able to analyze ethical perspectives concerning the roles, responsibilities, and rights of human and non-human actors and of broader institutions in promoting sustainability. Again, applying ethical perspectives can come into play in any number of courses. And the University of Vermont's learning outcome to address systems thinking aims for students to think critically about sustainability across a diversity of cultural values and across multiple scales of relevance from local to global. And finally, Pacific University in Oregon's strategic learning outcome is about the wide variety of actions that can be taken to achieve this meta competency. The goal is for students to design, conduct, interpret, and evaluate sustainable systems research using quantitative methods and reasoning. So all these learning outcome examples offer sustainability skills through a wide variety of disciplines. These could be used to guide or enhance courses in communication, writing, marketing, statistics, philosophy, sociology, public policy, gender studies, geography, plus all the hard sciences and engineering. So there's a place for all of these to really enrich a course. There's also some really fun ways to include the sustainability education in addressing some of these competencies. This is one example from Dr. Bethany Wiggin of the University of Pennsylvania. She created this course while she was a visiting professor at Princeton called Climate Storytelling for Climate Action. But she also makes this available as smaller units that you could infuse into a course. But it helps help students integrate kind of locally relevant climate stories into the topics that they're learning. Pretty dynamic setup that she's got, if you get a chance to look into that. And of course, there's always the option for more experiential learning, whether it's curricular or co-curricular. On the left side of the screen is a picture of one of our Sustainable Lab consultants. This is a co-curricular program. They get paid a stipend to work with our research labs as they go through a year-long sustainability certification program. Along the way, they learn lots of skills, intrapersonal, interpersonal, strategic thinking, futures thinking, values thinking. They have to implement and integrate things into the lab as a consultant in the lab. And it's been a wonderful experience both for our labs, but particularly for the students who have a real transformative learning experience. On the right is a picture of students in a year-long class. It's a 2-semester class called the Local Climate Action Program. And groups of students are paired with a local municipality to help them develop a climate action plan. Oftentimes it starts with doing a greenhouse gas inventory, communicating with the people in the community, communicating with leaders in the community, not just the folks that live there but don't work for the municipality. And it helps them use the data that they're gathering to develop their own climate action plan, whether it's in a very small township or a larger city. Also a great experience for the students to put their knowledge into practice, which is ultimately what we hope our students will be able to do. So we've reached the D, deciding on priorities and getting down to action. So how can you move these ideas forward? Use the tools. These competencies are available. There's lots of example learning outcomes that you can review and discuss with your peers in your programs. There are these best practices for integrating the teaching of sustainability. So use those best practices for great transformative and experiential learning opportunities, especially focusing on that, head, heart, hands approach. So one quick example that I hope will set your path, and hopefully we'll have time for questions. If not, one more quick example to help you get down to action. So again, we need to make sure that we can speak to how our work aligns with our current president's goals. At Penn State, that's something we keep top of mind because we want to keep on the top of her mind. So these are the 6 main Penn State presidential goals. And as you might imagine, it's kind of easy to talk about how sustainability education and internships and experiential learning support student success. That sustainability is inherently interdisciplinary, at the very least. Our work helps our communities grow and helps our impact as a land-grant university. And our work inherently fosters diversity, equity, inclusion, and belonging, and transforms our internal operations, particularly when we have classes working on living lab projects right there on campus. And of course, we work with our medical units as well in our medical school, and they are huge champions of this and are doing really cool things. That's a whole other topic for another session. But what we decided, what we came up with using those competencies was creating 5 learning outcomes for sustainability. These would align with the courses that earn that sustainability attribute I mentioned earlier. So we're looking at systems thinking so people can define sustainability and they have that consistent framework for it. They're able to analyze relationships and distinguish different system types, whether though they're sociocultural or economic or whatever. They're able to employ moral and ethical frameworks. They're able to identify designs and solutions and changes for a sustainable future, which is a real strategic thinking focus there. And of course, cultivating interpersonal competencies, helping them prepare to empathetically utilize others' ways of knowing and communicating to engage and motivate diverse stakeholders. These enhance student success. They help us grow our interdisciplinary research excellence. They increase our impact as a land-grant university, and they foster diversity, equity, inclusion, and belonging while potentially transforming our internal operations as we do these projects on our campus. So being able to speak about both of those things is how we continue to make a case for the importance of the work that we're doing. It's easier to get the students on board, slightly more complicated with faculty. And then, of course, administration wants to make sure that it aligns with what it is that they're working towards. So we definitely talk about those things, and I encourage you to do so as well. But those are our learning outcomes. You're welcome to use them as inspiration, plus any of the other ones that I've shared today. And of course, I definitely recommend referencing this publication. It was an honor and a delight to develop the education section and to see what best practices there are in sustainability education around the world. So you'll find nuggets about all of those. This is that publication from the International Alliance of Societies for a Sustainable Future. It's got principles and best practices in there. So take a look. And other things to help you get down to action if you are wanting to see if you are doing it right. The Sustainability Education Accreditation Commission is a fairly new organization, just a couple years old, designed to increase the quality, visibility, and impact of sustainability and sustainability-related degree programs to help prepare sustainability professionals and to evolve higher education. It's a third-party accreditor for sustainability and sustainability-related degree and certificate programs in higher ed, and they can offer some great insights, and they've got a lot of great tools available. So with that, I wish you best of luck getting down to action using this awareness, this information about the tools and best practices that are there. Get creative, have fun, and let's go teach this stuff better.
Thank you, Krista. To keep the time going, because we are still 7 minutes late in the symposium, you can reach Krista at the email that she's sharing on the screen or through the symposium organizers. And Krista, thanks for the QR codes at the end, 2 of them. I think they're going to be very helpful to many people. So we will move to our next speaker, who is here in person, and that's Emre Erdem from Sabancı University.
Good afternoon. I would like to thank the organizers, Alp, Bishop, and Dilben. Today I talk more on the sustainability of the materials. Is this one? Sure. Yeah. The green button, okay. And this is the button. So I'm from Istanbul, Sabancı University, and let me start with a very basic question. You know, in the late 1800 and early 1900, all electrics were electric, and then these are not used anymore, and we have 100 years long used combustion engine. But now in 2026, we are returning to battery-powered, especially lithium-ion battery electrical vehicles. So what happened between these 100 years long? World War I, World War II, energy crisis, technology and industry development. These are the reasons why we are now returning to battery-powered vehicles. Indeed, the electrical vehicles more than 100 years ago has 10 horsepower, and then Henry Ford is the man who is the boss, the first boss of Ford. They invented Ford Model T, and it has the first combustion engine working with the gasoline, 20 HP, so doubled. And it's much cheaper. So it was the pioneering point of the combustion engine vehicles. The thing is, here you see that Lamborghini, one of the strongest car motor, has 760 HP. Tesla 2026 model has 375 HP, half of it, and an electrical scooter has 1 HP. So now you can understand what HP scale is. Indeed, HP scale is invented by James Watt, and approximately 1 kilowatt is equal to 1 horsepower. So, based on this, we can continue. We can store energy in batteries or supercapacitors. The difference between batteries and supercapacitors are very clear. One of them has high energy density, the other one is high power density. Therefore, here you see a Ragon plot. Here capacitors having high power, and here batteries having high energy. The ultimate goal is to reach this point, both high energy and high power energy densities in one storage system. That is the most difficult thing, and you see here the supercapacitors. Here the supercapacitors is almost in between, but still we don't reach this region. Why we don't reach it? Because of very simple physics formula. Energy is equal to 1/2 CV square. C is the capacitance and V is the voltage or potential difference. The problem is you cannot go arbitrarily high voltages because the chemistry of the battery does not allow it, because there is an electrolyte and the electrolyte decomposes at above 4 volt. So you cannot go increase the voltage arbitrarily. You need a new materials. Also, capacitance is very important, but you need a large surface area. to accommodate more charges. And this is also a challenging stuff. Therefore, material science is very important in this manner to create high surface area and robust materials that are still preserve their properties at high voltages. That's the biggest challenge. Indeed, physics is everything in electrical vehicles, as you see here. If you have an electrical vehicle, all the physical parameters that you see here consume your battery, especially the slope, the mass of the car, and the others. The mass of the car is the most important thing indeed. So, this is the lithium-ion battery. He got the Nobel Prize in 2019. Good enough. Actually, normally there is a cartoon here, but since this is PDF, it doesn't work. But basically, the lithium ion is always going from anode to cathode and leave one electron here and come back here, and you get a current in this region. So this is how it works. So you need a lithium-based cathode and carbon material, which is mostly graphite. So here you see different types of materials, cathodes, electrolytes, and anodes. So you have plenty of choice. Once you have the mechanism, you can determine your materials by yourself. And each material here has their own property. And also the design is important. So you can design the batteries in three ways. Cell, this is cylindrical, prismatic, and pouch. After that, you can produce the module and then pack. So this is the pack that is actually the battery of the electrical vehicle. And if you look at, for instance, Tesla, they have 7,000 individual small batteries, 18650. One is the diameter, and the other one is the length of the battery. And it has mostly lithium, nickel, cobalt, aluminum, oxygen. And it is 540 kilograms. It's too heavy. What I said, mass is the most important thing. So if you reduce the mass here, you will gain lots of energy in your battery. So that's the main idea, how to reduce the mass of the battery of an electrical vehicle. So there are different chemistries. This is an example of Tesla. You see here Tesla battery chemistries in 2025. So there are 4 different chemistry in Tesla. NCA battery, so NMC battery, and LFP battery. Here the common element is lithium. Lithium is very important. And then you see here the other elements, nickel, cobalt, aluminum, nickel, mangan, cobalt, and iron phosphate. And each of them has different advantages. And each of them is produced in different locations. For instance, this one, NCA, is in California, NMC is in China, in Germany, and LFP is in China. And this one is unknown, and this is used in this very fancy vehicle. I think it's Cybertruck, and mostly it is NMC-like, but we don't know what is the chemistry in this kind of vehicles. So battery materials are important. They are here. I'm showing them. Lithium is one of the most important one, and as you see that lithium is mostly reserved in this region of the world, so South America, especially in Chile, and a little bit in China, but there is no lithium in Europe. And lithium is very interesting material because you cannot find it everywhere. You can only find them as a mineral, as a salt in this kind of minerals and as a salt. So you have to extract the lithium from these minerals, which is not easy. And these stones, these minerals, are either on the top of the mountains or on the bottom of the lake. So it's not easy to extract them. Therefore, you need to build some brine pools for lithium-ion batteries. And then here you see different procedures, but at the end you get a lithium-ion battery grade lithium element. So, for instance, this is the Chile mountain, the Andes mountain in Chile, and this is the pools in Nevada. Nickel is another important battery material after lithium. And as you see here, they are mostly located in Australia and Indonesia. But here the problem is Indonesia has problems of environment. You see here, they cut lots of trees and etc. to extract the nickel. And cobalt, they are also very rare in world. And as you see here, they are mostly located in Congo. And then the biggest problem is the child labor, because here to extract the cobalt, they use the children. The thing is, or the fact is, around 40% of an electrical vehicle's production cost is the battery. So you see, 40% of the cost is the battery. Now, if you look at the battery, only one cell, you see that the 80% of the battery is China dominated. So this battery cell is dominated by China, 80%. For instance, electrolyte 87%, anode 92%, because mostly it is graphite, and graphite is dominated by Chinese. How China dominate the battery market? Because they have lots of battery production factories here, gigafactories, and very little amount of foreign companies exist in China. And this is Shanghai region, and as you see here, different numbers of companies that are producing all battery tests. And plus, China companies are all over the world. You see here, and mostly they are located where these critical minerals exist. You see here, especially in Congo. See here, lithium, cobalt, nickel, and manganese. Where these elements are, the Chinese companies are there. So, the thing is, Chinese firms, the companies control over battery minerals. You see here, there's a statistical percent, and half of the lithium is for the Chinese companies control. Cobalt, nickel is little, graphite is almost all graphite, and of course, only controlling these materials that they need to refine. And if you look at the refining, in the graphite refining, which is the anode material, you see here 100% China. The others, cobalt, nickel, and lithium, China is also dominating the world. So how to beat China's control, especially in anode material, in graphite, because graphite is natural. So if you do it synthetically, you may beat them. But how to do synthetic graphite is not easy. But if you do synthetic graphite at the laboratory or at the factory, it will be much better than the natural, because the purity and the rate is very good. You see here the cost is very high, but the crystallinity is very good, and first cycle efficiency very good, and charge rate is also very good. But the cost is very high. But Tesla they produce and they use their synthetic graphites. The main problem of the synthetic graphite, to reach a battery-grade graphite, you need to reach 3000 degrees Celsius heating, which is very complicated. That's why it's very costly. So, in our laboratory in Istanbul, we are doing supercapacitors from vast materials like cigarette butts. Cigarette butts, you see here, they cause disasters, environmental disasters. People are throwing these butts to the cities, to the streets, etc. So we are collecting them, and we are trying, by chemical processes, trying to obtain a carbon material, which is called active carbon. The good thing with the active carbon is that compared to graphite, they are much lighter. So that means instead of using 40 kilogram graphite, you can use only half kilogram carbon in your electrical vehicle. So that is a mass saving. So we do this and we obtain good results. Of course you can, so this is a waste to value. We also do other materials, organic and inorganic materials like end of life tires and coffee, banana, etc. So we get different types of active carbon from waste. For instance, this paper is from the tea waste, this paper is for the coffee waste. Also, you can use some meteorites for preparing some different types of supercapacitors, and you can get different types of supercapacitor results. And as you see here, as you see here, we did some characterization for the meteorites, and in meteorite we have seen manganese incorporation in the meteorite, which is a metal ion, and this will increase its conductivity, and you can use it for an electrode material as a supercapacitor. Alternative to lithium ion is I can't see them there, but solid state batteries, lithium sulfur batteries, sodium ion batteries, and metal air batteries. These are all different alternatives for the lithium ion, because you see lithium is limited. Therefore, we need to find better performance and to get rid of lithium, but it is not easy. I have here one table or one spider chart. As you see here, the comparison of all types of batteries. So they gave here a kind of score in terms of their specific energy, environmental friendliness, cycling performance, cost, and cycle life. You see different chemistry of these batteries. These are mostly lithium ones. As you see here, and these are the lead acid, nickel cadmium, nickel metal hydrate, zinc ion, etc. As you see here, the highest score still lithium ion, 3.9 here, 3.9. So based on these performance parameters, no other chemistry can beat lithium ion batteries. That's the thing. So although you find better alternatives for lithium ion, just keep in mind that it will not be as good as lithium ion. That's the biggest problem as well. So here you see the next generation batteries targeted by this SoftBank. This is a Japan company. And as you see here, currently we reach 300 watt-hour per kilogram, which is very high. And near future, by different kinds of chemistries, they want to reach 1000 watt-hour per kilogram. With that, you can reach at least, without charging, more than 1000 kilometer range of electrical vehicle. Other stuff, you see, this is, I can skip that. You see here flow battery. Flow battery is also another type of materials application in energy storage, especially they are using vanadium oxide, vanadium redox system. And as you see here, this is a complicated working mechanism. And then they have this kind of containers where the redox flow batteries are inside. So that, but this is good for stationary systems, not mobile systems. Why? Because of this, you see here there is plenty of liquid inside these kind of flow batteries, and therefore it is better to use this kind of systems as a stationary storage systems. So last, I would like to show you the recent study that we are doing. We are trying to understand the relation between the microplastics and a hip fracture of a human. So we have a collaboration with the hospital. There are orthopedic chirurgs. They do operations to their patient, and they remove the head, femoral head, which is this one here. Mostly this part is broken. So we are trying to understand if there's a relation between the microplastics and this fracture, which happens mostly for the old people suddenly, without any force. When they are sitting, their hip broken, and we are trying to understand this. And you see here, this is the picture of the sample. So they remove. This is a paper that we are still under. We are preparing. So this is then. It took 2 years to get an ethical permissions. Here you see the operation. They remove that part of the bone, and then we clean this blood stuff, etc. All things, and then the final bone. After some milling, we get this and drying, etc. We get this as a sample. So we have measured this. Raman spectroscopy is one of the best way to observe plastic vibrations, and these plastics, polypropylene, polyethylene, and polyester are the most popular ones. And then we observe their typical Raman peaks in different positions. As you see here, high frequency as well. And then as you see here, that all these polymers that you can find in food containers, yogurt cups, bottle caps, drinking water bottles, soft drink bottles, disposable cups, takeaway food boxes, etc. So we have seen in these old people's bones that they have the fracture, these popular plastics. So take-home message is this: what we design as polymers today may return tomorrow as microplastics in the human body. This makes sustainability in polymer science and the development of safe ceramic materials a direct responsibility for human health. And with this, I would like to thank our collaborators, and thank you for your listening.
Thank you. To keep up with the time, we will move to the next speakers.
Yes.
We will have Till Frömling from Darmstadt University.
All right. Do we have a clicker? Is that it? The green button. Okay, perfect. Yeah. Oh, sorry. Thank you very much for having me here today, and welcome. Rishabh and Krista were already talking about our joint endeavor on a report concerning sustainable universities. And we did this on behalf of the SFS, and also this included contributions by Daniel Isaiah and Patrick Breckner. Now, when we're talking about sustainability, of course, this includes ecological goals and societal goals. I will first focus on the ecological ones and the relationships to universities, but I will try to also include the relationship to societal goals where there may be conflicts or even synergies. So why universities matter? So sometimes I hear two different opinions. So why should we hear about or talk or take care about what people say at universities? They don't know anything about the real world. Well, in that case, we should stop researching at all, probably. But the next, I think, is quite interesting. If even people at the university do not take care about sustainability, why should we? And so universities should always be testing grounds for new development, and so it should also be testing grounds for sustainable behavior. And we have the chance to influence many new decision makers with our teaching, and also with the large facilities, buildings, labs, and so on. It can be an absolutely ideal testing ground also for research. Right, so we have different dimensions with which we can influence sustainability at the university, now focusing on the ecological goals, of course. We have mobility, teaching and curriculum, and infrastructure and governance as the respective pillars. Now, with respect to mobility, this is very often not disregarded, but underestimated. So for some universities, the emissions can make up the majority if you count in the travel of staff, students, and visitors, and it has an everyday influence. But of course, there's a certain context dependency. So where is the university and how large it is? But I will elucidate this a little bit more in the next slides. What general opportunities do universities have to influence that? So basically we could improve public transport, not only kind of offering public transport, but also reducing costs for public transport for the staff. Prioritizing cycling and walking. If cars are necessary, manage the parking, electrifying of the fleet, if there is a fleet in the university or a higher education facility. And one big point is business travel. So shift business travel towards more sustainable solutions. One example would be, for example, the EPFL in Switzerland. They say, okay, we should not have any flights within Switzerland, and any travel that can be done by train within 6 hours, that should be preferred. That's already quite significant. So we have in Lüneburg, as an example, we have the introduction of a fully pedestrianized campus, and also University of Washington. Here we have the support, for example, for car sharing and bike rentals, just as some examples here. Now, generally in Switzerland, also not only at EPFL, but also at ETH, this strategy of trying to reduce business travel, or not necessarily only reduce business travel, but the ways to do business travel, is also implemented at ETH, and they actually investigated the impact which this should have. And so they identified with their travel applications how many people, so the FTEs, the full-time equivalents, are actually traveling, and how much absolute emissions that this would generate depending on how they are traveling. Naturally, 2020, 2021 was a year with low emissions due to COVID, of course, but even afterwards, after implementing these travel restrictions, they could see or show that they were reducing their absolute emissions quite significantly. So it's always also very important to have kind of metric to see what impact your goals and what your strategies have. Right, so with respect to teaching, it's of course good to have studies or single courses about sustainability, but to take over all of the courses and introduce sustainability aspects is, I guess, the most important role of a university. So very often you can hear the term campus as a living lab. And I also would argue that is one of the strongest models in the sense of that even if you have some sustainability related research, that some projects at least have a direct impact on the university itself. So there is an example of the University of Pennsylvania. So they included sustainability related topics in all 12 schools. Also at the Sabancı University, where Emre Erdem is coming from, our previous speaker, designing of new courses with interdisciplinary aspects. And the Zhejiang University has SDGs, so the Sustainability Development Goals from the UN, included in the respective modules. With respect to infrastructure of governance, we of course have the buildings which consume or have a long-term energy demand, but this of course also includes the handling of water, waste, taking care of biodiversity, and even procurement of equipment which we need. With respect to governance, we could have encouragement of sustainable decision-making among students and all of the university body, and setting clear metrics. And this is what I was alluding to before, really having a tracking process of all those respective measures. So when we are talking about infrastructure or waste disposal, for example, here in Mexico, compostable garbage bags, waste sorting, reusable containers. We are talking about encouragement for sustainable decision-making, having actual campaigns, for example, the Say No to Single-Use Plastics, and here University of Vermont, this is a rather kind of setting metrics and infrastructure aspect with an energy plan of measurable renewable energy and implementing electric vehicles. So now that we are sociologists, of course, we are usually involved in working in the lab, and especially as the ceramicists ask themselves, okay, how high will my contribution to the sustainability of the team should be? And for example, the University of Sheffield has evaluated that the wet labs or chemistry labs are only like 7% of the floor space, but are responsible for 50% of the reported emissions. I ask myself, okay, if I'm using large furnaces for sintering, how high would the can be compared with? And a lot of times now we are talking about AI. And a lot of universities are saying, okay, we need local LLMs for the students because we don't want them to use the commercial ones. And so I asked myself, how high would the energy consumption be of such an localized one? This can be reasonably broad range, but for a medium-sized one, for like 20,000 students, it's roughly in the range of a medium sintering furnace average over the year. And so me as a researcher in ceramics or wood dealer probably can do a lot by taking care of trying to reduce my footprint and being more sustainable. And this leaf practice was also already introduced is, for example, something which can already be done on lab level, so not necessarily need to think about the higher level of university politics, which maybe not everybody wants to be involved with him or herself. And so we have not introduced it yet, but we will definitely try to do that. So then there is the aspect of large versus small urban versus non-urban. So if we have a large institute, of course we have a lot of opportunities and we may have a large impact, but that's usually very slow, while the small higher education facilities can be very agile while having rather small pilot project options. Then urban versus non-urban is also an aspect where it's mostly concerned with mobility, of course. If you are in a non-urban area, you may not necessarily be able to facilitate support for a lot of alternative mobility options. I would also even say that it really depends on which country the university is. I gave the example of Switzerland, and I didn't even know that you can fly from one city in Switzerland to the other, because it's really comparatively small. If you would like to implement that in Russia, China, or the USA, I'm not sure whether this is actually feasible. Right? So you would need a 3-hour ride from Boston to Seattle, and I don't know, it's a nice conference. Ready to travel 3 days just to be more sustainable in this way. So how can sustainability be assessed, or how should it be assessed? And it should be kind of equally at the same time amongst these different aspects like government's leadership, curriculum, energy, carbon, water, waste, mobility, and also engagement and reporting. Again, an example for the labs. There has been a study or pilot study in the UK. They had 335 labs evaluated, and they could show that about 650 metric tons could be avoided during implementation of the strategies. And one thing which always is an incentive, they calculated the average money saved for the respective labs. 70% of that has gone to energy savings, 20% was kind of efficient use of material, and 8% was the waste savings. Other aspects are more on a higher order. We have already heard from STARS, but similar UI Green metric or the Times Higher Education Impact Rankings, they are more or less similar, but have the similar goal. Also, BREEAM is more focused on building certification systems, as is LEAF more for laboratory sustainability. But we also need to ask ourselves, are measures that hurt in a sense, are they accepted? And again, going back to the ETH study, we can see that the overwhelming majority at least approve somewhat with these measures. Again, that may not necessarily hurt if you have a good train system and a reasonably small country. I don't know how high the acceptance would be in larger countries, of course. But this shows that the awareness is there, and in these cases, this has been successful. I told you that I was going to talk about the ecological goals, but now let's see whether there could be conflicts or even maybe synergy with some societal goals. And just as an example, I would like to take up again the pedestrianized zone in Lüneburg, which is nice. Walking is healthy, right? So that is great. But we need to make sure that this doesn't give us some social barriers, right? So if we have minorities, disabled people, right, we need to make sure that they also have a similar access to the campus as other people do. However, it's not only the conflicts that are there. I would also say that there are synergies. I mean, let's take the symposium. We have a hybrid symposium, right? And probably I'm the least sustainably acting person here, traveling from Germany to Seattle to give a talk about sustainability, while a lot of colleagues who have contributed here actually stayed in Germany. And I think it cannot, or a digital version cannot completely replace an in-person conference, but my argument would be it could extend it. It would reduce the ecological imprint, and if we are thinking about the societal impact, there are a lot of young students or researchers who don't have that much travel money, or people who have children, parents who have childcare and are not able to be on conferences that much, so they have more access with those hybrid ways of having a conference. Right, and as Yannick, Rishabh, and Krista were going through the US and talking about the respective report, they were kind of identifying that there might be barriers to develop a sustainable culture or a culture of sustainability. And in the second report, it was categorized with a scheme by Edgar Schein, Organizational Culture and Leadership. And there it's separated between artifacts, espoused values, and basing underlying assumptions, what people are doing. So the first part, the artifacts, is basically the tip of the iceberg, which can be seen by everybody, right? So this is the best practice observable behaviors. The espoused values, so how the university would like to present itself, is kind of just below the waterline. But what is usually driving the people in their actions are the basic underlying assumptions, which are very often unconscious. A larger challenge for the university is that there might be so-called sub-collectors, which means we have faculty, administration, and student body, and very often different practices and sometimes maybe even competing cultures. And the sustainability should entail everybody in the university. So what conflict would it be? Of course, this kind of involves, or these are correlated. So we could, for example, have a visibility gap on the tip of the iceberg, which means there is a researcher that has an awesome invention which saves energy, and it's reported in scientific journals, but this may not be known to a person in the administration working in a legal department. So there is a detachment between these groups. And this could lead to something called interinstitutional inconsistency, so a disconnect between the green mission, this is now then something scientific, and only the researchers are taking care about the sustainability, and what is my role in there, right? So this is kind of something that could happen. And eventually, this leads to a deep decoupling of the sub-collectives. And so I cannot contribute to sustainability because this is something which only the academics do. And so any measure should actually include everybody in the university, or at least a lot of the measures. For example, to decrease the visibility lab, so living labs having direct impact on also other aspects of university life, having a sustainability charter or forum where things are explained, so this also involves science communication, of course, and also general policies that increase sustainable actions. So one best practice example would, for example, be University of Louisville, and they really explicitly support campus as a living laboratory. They have a huge range of overlapping projects for different fields and connect them with applied learning. For example, student-developed car-free guide, which can be then directly supported by the overall body of the university. Students support the bottled water phase-out, so for more reusable cups, or geodata-based work then help to map out a campus stormwater system so that stormwater can actually also be used. Just as an example here. Right, so what opportunities generally at the university, or where should we start? So of course there's the baseline, what emissions do we have, energy, mobility, curriculum, buildings, what options can we really have to generate projects, then priorities of course need to be made. visible pilot projects for everybody with educational value need to be generated. Then linking the projects to metrics, is also very important. So what result do we actually generate from that? And hopefully then scale it into institutional policy. With that, I would like to end, again highlight the accessibility of the report through the SFS site. I'd like to thank you for your attention, and looking forward to questions if there are any.
Do we have any questions? Yep.
Sorry. Thank you, Till. So I'm not very well versed in this field, so this might be an obvious comment, but I think transparency in people's actions might be a useful way to develop an awareness of their impact on sustainability. And if you look at food labeling in the US and the EU, I think that's a good example of how there's information there for people to be able to take actions and recognize if they want to limit sugar or salt or whatever. I wonder if there's a way to use that to kind of help make policy more effective for people to understand, with every time you send a tweet or use an AI model to generate an image, to have some transparent way of understanding how much energy or carbon or some unit or use transportation or something like that. Are there any examples of that being used to try to help with people's transparency in their impact on the environment?
Yes, I mean this is basically I would argue included in what I said with metrics, right? So if any change is made, what impact does it have on emission or the overall waste production, for example? And there are examples in cafeterias who showed, okay, what kind of waste production is current and how they reduce it or have reduced it due to implementation of reusable cups or something like that. So this would be, in my opinion, already quite illustrative and is implemented because this is something where a direct impact of oneself's action can be shown or can be made visible. Yeah.
Great. Thank you.
Thank you, Dave. Are there any online questions? No. All right. Let's thank our speaker one more time. Our next speaker is Kristen Ellenbogen from the Science Museum of Cleveland.
Hello, hi. I'm hoping I'm coming through. I'm just getting a blocked video signal. I'm hoping that's something you can undo on your end.
We are looking into it right now. We can't see your picture right now.
Okay. Well, I want to be respectful of the time. There we go. Start my video. All right. Oh dear. Vicky, would you prefer I sign out and sound back in again really quickly?
I'm waiting to hear from them. Just a second.
Okay. Thank you all for your patience.
So you cannot share your screen, is that?
It says that the video is blocked. I'm getting an error message when I go to share, when I go to open my camera. Okay. All right, I see it works for Krista. I can leave and come right back. I'll give it one more try.
Thank you.
Yes, no problem. All right. Thank you for your patience. I think that's working now.
Yeah, we can see your camera.
Okay. Thank you so much. I'm really sorry about that. I'm Kirsten Ellenbogen. I'm president and CEO of Great Lakes Science Center in Cleveland, Ohio, as Alp said. And I'm here kind of wearing the hat of being the immediate past chair of the Advancing Science Communication Committee of NASEM, the National Academies of Science, Engineering, and Medicine. And we spend a lot of time working with experts like yourself to think about the best approaches for science communication. It's its own field of research, so we spend a lot of time making sure that the research is getting out into the many fields. And my talk today is based on work we're doing to integrate science communication as a competency more effectively into graduate studies, so that we can move towards this use of science communication as collective action as scientists. I know that science communication, it's easy to frame it as something that is simple, like explaining complex ideas clearly. But there is a great deal of research on this that tells us that it's something very different. Effective science communication is not simply about clarity. It's about understanding people, understanding systems, trust, and society itself. Science communication cannot be reduced to tips, tricks, quick training modules. It requires a set of foundational competencies that shape how scientists think, not just what they say. So I have 6 core competencies to propose today. They form the foundation of effective science communication. Again, they're not techniques, but they are ways of understanding and thinking about a world that makes science more accessible. The first competency is developing a civic science mindset. And what that means, this foundational concept, is that science doesn't exist in isolation. Scientific issues that which you choose to study, that where the funding is focused, whether that's climate change, public health, material science, they are not purely scientific problems. They have societal elements to them that involve values, trade-offs, diverse perspectives. So a civic science mindset asks us to see ourselves as participants in public life, not just as experts. It requires us to recognize that many stakeholders, not just scientists, have a role in scientific issues. And it requires us to value different forms of knowledge, including people's lived experiences, as a factor in our research. And that's a shift, right? It's a shift to a civic science mindset. And it means that instead of asking, how can I get people to understand the latest research I'm conducting, you start instead with a question or even a conversation around how do we create spaces where different perspectives, including scientific ones, can interact productively. And we even heard some of this in the most recent talk, right? The intersections of the lived experience of the science we're doing. Now, this kind of competency does emphasize an asset-based approach. The idea that people that we're working with out in the public, they're not empty vessels, right? Our goal is not to make sure they understand exactly what we're doing. There is this expectation that everyone we're interacting with does also bring knowledge, experiences, insights. And without this mindset, science communication really does become one directional, and we lose our opportunity for collective action. With a civic science mindset, communication becomes participatory and it becomes inclusive. So that's the fundamental competency. The second competency is about understanding the information environment. Now, that means that you're recognizing that science communication happens within a complex information ecosystem, right? We don't control the way our work reaches the public, unfortunately, right? Instead, we've all seen this. It might flow through news media. It might flow through social media platforms. It flows through the institutions we work at. It flows through algorithms that sort and prioritize the information we've got to share. And it also flows through cultural and economic forces. So what does that mean? It means that you doing research does not mean that you get to dictate how that gets out to the public. The systems of information are too complex right now. It means a university, right? The institutions we rely upon, they cannot fully control how messages will spread. And it means that audiences are going to find science across multiple overlapping channels of information. And because of this, it's even more critical to keep in mind that those audiences are not passive, right? They're moving very fluidly between something that they might hear in a lecture, something that they're seeing on the news, something that they're seeing in social media. So understanding that complex set of really the environment out there that our information is going out into is going to help us be better consumers of the information and be more strategic in the way we contribute to that public dialogue. It also highlights a key reality. Science communication isn't just about speaking, it's about navigating a system that you don't control. So that brings us to the third competency, and that is about building and maintaining trust. It's arguably the most important, and it's probably the most misunderstood element of science communication. Trust is multidimensional. It's not a single thing. It includes how people perceive expertise. Do they think you know what you're talking about? It includes perception of integrity. It includes perception of benevolence. And it includes the perception of openness. Do we appear to be willing to listen? Now, we are trained very explicitly to focus on the first, expertise. And that's been an important part of our work, our studies. It's the way we're trained. But research shows that trust does not depend solely on our expertise and instead integrates in key factors like empathy, our humility, our proven ability to listen, and our ability to demonstrate a shared interest. In other words, being right is not enough. So if audiences perceive that you don't care, that you're not listening, they perceive that you're dismissing their concerns, communication breaks down, regardless of how strong your research is. So this competency challenges us to move from how do I prove I'm credible to how do I build a relationship that people trust. That gets us to the fourth competency, which is practicing an intellectual humility. What do I mean by that? It's a recognition that scientists do not have all the answers, that knowledge is always evolving, and that audiences do hold valuable expertise and perspectives. This isn't about undermining science, it's about strengthening it. It involves acknowledging that science processes are complex. It's about acknowledging that science changes. It's about acknowledging the uncertainty in everyone's research. It's about reflecting on our own biases, recognizing how our identity shapes our perception, and engaging in ongoing self-reflection. It also aligns with key principles of inclusive communication, our intentionality, our reciprocity, our reflexivity. So these are especially important because we have to remember we are not immune to bias. Humans are not immune to bias. Our brains are built, right? And we work very hard against this, but our brains are built to have bias. And if we don't recognize our own assumptions, we risk misinterpreting the audiences, reinforcing inequities, and damaging trust that we've worked hard to establish. Humility from this perspective is not a weakness. Humility is a core strength of science communication. The fifth competency is understanding how people think and decide. And this really gets at a common misperception. There is this misperception that people reject science because they lack information. They lack the context about it. They lack the understanding about it. And hopefully you know this, we call that the deficit model, right? And that certainly may be correct in some instances, but there are so many instances where that is not what's keeping someone from adapting the science that we're sharing or understanding the science that we're sharing. People don't make decisions solely based on evidence. Instead, thinking is shaped by values, by beliefs, by experiences, needs, social structures, the constraints of the situation. Even as scientists, we're influenced by these factors. What does this mean? Well, it means that we have to keep in mind that presenting data does not automatically change minds. And there is decades of research on this. In some cases, presenting evidence as the only factor can backfire. Effective science communication requires understanding that people engage with science for different reasons at different times, that information is filtered through personal and social contexts, and that behavior is influenced by more than a person's knowledge. So when we're working with grad students to really take on this competency, it helps shift them from how do I explain this better to how do people interpret, use, act on the information I have in their life. The sixth competency is based on strategic communication, right? And the idea is to really say we can prepare graduate students and ourselves with strategic and goal-oriented communication. It means that effective communication of our work does not start with content. It starts with a question of purpose. So key elements might include defining your audience, clarifying the goal of why you're presenting the research to that particular audience, identifying specific audiences within the group, and choosing an approach that fits both, the audience you're talking to and the resources they have on hand. It also involves understanding that sometimes the very best science communication is a team effort. And this means that we can bring in professional communicators, public affairs specialists, community partners are a key piece. If you're working to get your research out into a particular community that's most affected by your research, bringing in community partners, finding out who in the community really can work with you to express the messages and help you understand the perspectives of the community, the needs of the community, the existing understanding and knowledge of the community. We call a lot of those people boundary spanners. Although you may be working with your graduate students to really make them effective boundary spanners. That means people who are really working across the disciplines of science and society and pulling those areas closely together as a boundary spanner. The other piece of this competency is evaluation. So following up to understand, did the communication reach its purpose or goal? How do you know that? Can you confirm that from different sources? And what should change next time? This competency really emphasizes that communication isn't just an act, it's a process, right? It's something that we can design, we can test it, and we can improve it over time. I do want to talk about, these competencies, the 6 competencies I've talked about. It is a set of skills, but I want to be clear that it's not something that we can use as a checklist. It really is about engaging ourselves, our students, in shifting mindset. So really coming to embrace the understanding that science communication is not just about what we say, it's also about how we understand people, systems, and our role in society. These 6 competencies, the civic science mindset, understanding the information environment, building trust, practicing humility, understanding human decision-making, and communicating strategically, they do form a foundation. These competencies remind us that community interactions, the communication we're engaging in, it needs to be relational, not transactional. And we need to think about our audiences as partners, not as problems who have trouble understanding what we're presenting. We have to really acknowledge that science exists within society. Our work does not exist above society. If we want to make science matter to the world, if we want our research to be valued, we have to move beyond simply sharing knowledge and towards engaging meaningfully with people. I want to close at 7 and respect the timeline and make sure I can still take a few questions if we have any.
Are there any questions? I have one question. So, as you say, sometimes we don't own our own voice. How it goes to the public goes through many layers, and we also still have to keep the trust and that the people have on us. While there's a counter also, it's easy to put doubt in people's minds than to be able to provide them maybe a more complex architecture of ideas, and it's easier to knock it down and to build it. And trying to do that, or trying to still keep it while not controlling our voice necessarily. As you say, there are ways to do it slowly, building from the community up, which again sometimes feels time consuming.
Yes.
When we feel like also we have very limited time left to make a real change with the climate change timelines, etc., that are going on. It just sometimes it feels overwhelming. So is there a way, if we feel like we need to speed this up, is there, I don't want to say shortcuts, but are there any ways we can spread this much faster in a bigger way than building community up?
Sure. Yeah, well said, Alp. Absolutely. This is such a struggle, right? As if there's time to get everything I've just discussed done for every big piece of research you're trying to get out there, and particularly because we don't control every channel of information that research might be communicated through. good question on a shortcut. And I would argue that boundary spanners, community leaders, those are our shortcuts, right? So the work can spread so much more effectively if you find that person in the community who has already built up the trust, who already has a broad repertoire of influence in the community you're working with. Working with that boundary spanner, working with that influential person in the community is the shortcut, right? To have someone like that, so influential, so informed, to inform you and help you kind of really build in that perspective of what are the needs, what are the priorities, why might the information I have be more or less valuable to this particular community. Being able to get that information from a trusted source. And I will put in the caveat that it can be hard to know if the person you're talking to in the community is a trusted source. But establishing that, right, we all triangulate things, and using that boundary spanner, using that community influencer to help you really is the best shortcut that I can recommend.
Thank you. For the time's sake, thanks our speaker one more time. Thank you, Kristen. So we will go to our next speaker, who is here in person. That is Rishabh Kundu. We'll be talking about bridging the divide.
Thank you, Al. Hello again to everyone who has been persistently listening since morning, and my greetings to also the couple of new faces I see here. We just learned from Kristen's wonderful talk that there are these barriers of communication, and there are these multiple gaps or variables which come in between what we want to say and how it is received from a policymaker, or how it is received from someone who we are not really talking with. And through this cross-cut collaboration, Dr. Haixin Dang, my co-author, is an assistant professor at the Department of Philosophy. We want to present some conceptual tools so that you can get the message through to those rigid heads who just don't listen. Ooh. Sorry, that was the wrong remote. This is the right remote. So before initiating any sort of bridging, we must be very, very clear about the problem, and we must acknowledge it. We saw these graphs even in the morning, and I'm not going to go too much into details for the sake of time, but if you see from the 1950 trend, when also the global GDP kept on increasing exponentially, that as we kept using more energy, more water, and our population grew at the same time, our carbon dioxide level, our ocean acidification, and our other adverse effects on Earth is also very, very evident. So it is imperative to adopt sustainable practices, and then we cannot bridge any narrative unless we are very, very deep-rooted on this common message. And when I say sustainability, I will like to be frameworked or boundaried by the definition which was put forth by the UN Brundtland Commission, and which can be seen here. Coming back to science and policy, we often hear that everything's ending and the world is getting over and stuff, but I would like to start with a positive message. The Montreal Protocol, which was signed by all the United Nations members in 1987, and this abolished the use of ozone depleting substances in all sectors, well, with a catch. If you look at this figure here, blue is bad, everything else is good. Blue means that your ozone is not present there. So our ozone layer is healing. Yeah, that's good news. So it seemed like science and policy worked there, right? Scientists said in 1970s, hey, we have this problem. Policymakers came together, just took 17 years, and then we have a solution. This is not the whole picture. Professor Brookman, an associate professor at our department, her family is in the refrigeration business, and they were very pissed by the Montreal Protocol. And this was because the refrigeration unit, or the refrigeration sector, was the first sector which was asked to switch to substances that do not deplete the ozone layer. And this was not something which the scientists recommended. The scientists recommended a switch in all the sectors. But based on who had what level of influence in Congress, different sectors were allowed to switch at different times. And this is in one country. There is no disparity of a developed or a developing country here. Thus, there is a gap between science and policy, and this gap is often the gap which is exploited even in terms of climate change, anthropogenic climate change. The most common way of exploiting this gap is the term uncertainty. If you look at the English language definition of this term uncertainty, it's the state of having limited knowledge. But we looked up some statistical modeling uncertainty. This is something as material scientist or engineer you all impart into your work also. The plus and minus factor in your results, right? Nothing is absolutely static. There are three very scientific definitions of uncertainty in statistical modeling. It's aleatory, epistemic, and ontological. And we acknowledge all of these kinds of uncertainties in our works. Even climate scientists do that. The first two are quantifiable, the last one isn't, because it is something which we don't know that we don't know. So, of course, we cannot quantify it. Thus, there is a distinction between the English language definition of uncertainty and how it is perceived by scientists or the scientific community. And this explicitly scientific definition, the PDF got smeared in the second part, I apologize for that. This particular scientific definition of uncertainty is presented, highlighted very clearly in all sorts of work. If you look into this model and different scenarios, the two kinds of uncertainties which can be quantified are present here. And there is always the ontological uncertainty which is presented in a qualitative form. Now the conceptual tools which I was mentioning earlier is that we should avoid debates which concentrate on this uncertainty factor, because the doomists, the denialists, or even the confused people, they always say, oh, the scientists are uncertain, it's not going to happen, blah, blah. We must bypass that, and we must understand what is going to be the situation at our local community, at our local areas, focusing on the here and now. And based on the people you're talking to, so for instance, if I'm talking to Ryan, I don't think I have to convince him, but just in case I am, I will tell him that, oh, you know what, your house is going to get flooded because of these climate change influences. You don't have to be very direct about the impact of climate science, because you can convince them from the effects they have, or which can be perceived right away or in a short-term timeline. We are in Bellevue. It's a very pretty place. Mount Rainier National Park is very close to it. I looked up what are the local effects in Bellevue, and I found out that there's going to be an increase in precipitation and heat, which means that there's going to be higher property damage. So your insurances are going up. It doesn't matter what you believe. The insurances company know what their risks are. So they're going to increase your premium. They might also not insure your house. There will be commuter disruptions due to higher precipitation, school and work closures. And that might sound funny, but that affects the economy directly in a short term. This is something which is not very new, playing around with uncertainty. The tobacco industry did this for almost 40 years. And this comes in from this very nice book, Merchants of Doubt, by Naomi Oreskes. If you look at the third point there, it was very clearly expressed in an internal memo that doubt is their product which they can sell to the general public. And then using the tool which I just mentioned, talking about the here and now, there was a scientific consensus which was reached, which was communicated directly to the patients, and then other institutional actors came in together. So instead of directly talking about, climate change, they talked about you're going to have lung cancer. It's going to affect your family. You're going to pass away before your usual lifetime expectancy. But this process took 40 years, as I just mentioned. We do not have that much time. We have already transgressed 7 out of the 9 planetary boundaries. Yes, it's 7 now and not 6 as the popular science paper. I bring to you some US-centric examples. which I could find out together with Haishin. So the homeowners insurance market, faces significant challenge from the climate change, especially on the coastal regions. And insurance companies have accepted this. They know that it is real. And their prediction models say that, they're going to have a huge loss if they insure your home next to the coastal regions or in high-risk areas. And if you want to fight against this insurance problem, you got to have a collective action. And when you're having this collective action, you need aligned social and political values. So instead of directly going in from climate change, you're talking to people about, your insurance is going to increase. What can we do about it? Let's get the community together. All right, now we have some aligned values. And then this will ultimately go back to anthropogenic climate change, to the policymakers. And this ultimately, in our opinion, may lead to bridging the gap, especially in American culture. And we were just hearing from Till that how we can have this culture-embedded sustainability. My take-home message to you is that for all the people, and these are all from the PDF conversion from the presentation, I believe, for all the people who are denialist, doomist, or confused, we gotta meet them in the middle way with things that they can comprehend. Insurance, health, money. Science alone cannot bridge this gap. Once we form a bridge over here, then science can form a better bridge with policy. That was all from my side. Before I take some questions, if the session chair allows, I would like to greatly acknowledge my advisors and my mentor who is online. And I would like to specifically acknowledge Case Western Reserve University's fellowship courses. I met Dr. Dang because I took a course named Introduction to the History and Philosophy of Science, and Case paid for it outside of the obligations it has for my compensation. And this is how we formed this collaboration, and this cross-cut talk came to being. And if you want to get connected with us over LinkedIn for further discussions, comments, feedback, here are QR codes, and this is Dr. Dang's website. Thank you.
Do we have any questions from the audience? Yes.
I believe you will have to talk in the mic so that the people on Zoom can hear.
I have a comment and a question. I think your message is clear that this is one way to get the message out. My problem with this is that it really does not value at all the common good aspect of it. And as a result of it, if you tell somebody who has enough money to pay for the higher insurance, they would not care about somebody who doesn't have that kind of money. So I think at some point, we live in a society where we have to also worry about the common good rather than only our self-interest. So that, to me, is somewhat short-sighted to focus only on the short-term individual interest.
Thank you very much for the comment. Maybe there are people who have the capability to pay higher insurances, but the investments and other things which they have, I think no one in general would like to lose money. But yes, I completely understand that there are also self-centered people who cannot focus. But if you want to form a community of people who are coming along and focusing on what we would like to do, which is to take action against anthropogenic climate change, I think at one point the policymakers will have to listen to us, irrespective of that short population of self-centered people.
Thank you.
Thank you.
And that's always, there's always more to discuss. Thank you, Rishabh. And those of you who are here and online, we have a student competition coming now. And this will include both voting by the judges as well as by the audience. Please stay around and make sure to vote for the students that are going to present now. We're starting now, right? Yes. Do you want to do the introductions? And we have our judges here. Hi.
All right, hello everybody. The student event is beginning. We're going to be having people join online shortly. Our first presentation will be in a second. I have it scheduled out. But yeah, the point of this competition is to kind of promote student involvement in sustainability. There were several talks earlier today about how universities play a very large role in pushing and providing direction for sustainability for humanity and for the world. And I think a very large portion of universities is the students. So if we can incorporate students into these sustainability actions and the sustainability policies, and even just like day-to-day actions kind of a thing, it's a very important step into having a more sustainable future. So the point of this competition is to promote that. The presenters were given a prompt to think of 2 to 5 different ways in which, as a student, you can make some simple lifestyle changes to be more sustainable. And they'll be doing 4-minute presentations on those steps that that are unique and that they've thought of, with 1 minute for questions after each presentation. We will start in a second. I need to go look at the schedule really quick. But yeah, so without further ado, that is what's going on. This QR code we will be using at the end. There's an audience choice aspect of this. There are 2 categories. There's a judged category with a $300, $200, and $100 first, second, and third place prize. And then there's an audience choice category with the same prizes for first, second, and third place. So at the end, we would really appreciate it if you could take a second to vote as to which presentation you thought was the best, which one you thought was the second best, which one you thought was the third best. We're going to be doing some ranked choice voting on that. So yeah, give me a second to go get a little bit more organized. We can get the rubrics out to the judges, and then we'll go ahead and get started. So thank you so much.
The students that are online right now getting ready to present, some of you joined as attendees rather than panelists. So when we send you a request to become a panelist, please accept it.
All right, so our first team that's going to be presenting is Dora Elise and Satalinta Sechai. So are you guys online?
Yes, we're here.
Awesome. Are you guys going to be able to share your screen with the presentation?
Yes, actually, we are using both our laptops. I am going to be using the audio is from mine, and the presentation will be from my partners.
Can you
Awesome.
please confirm if you can see?
That we can see the presentation. So go ahead and get started whenever you are ready, as long as the judges are ready. Are we good? Okay, I'm going to take that as a yes. Awesome. Go ahead and get started.
Thank you. Hello and welcome everyone. I'm Dora Victoria Yish and my wonderful teammate is Satir Deshahai. We are from Research Group Matur at the University of Cologne, representing the German chapter of ACerS. And today we will present Suspaka, an app concept designed to help university students make sustainable lifestyle changes more easily. During our ideation phase, we found that many sustainable options already exist for students, but they are often overlooked or feel inconvenient to adopt. So Suspaka addresses this by presenting practical lifestyle changes in a format familiar to students, aka Gen Z. Right now, it's a smartphone app. This app groups actions into 5 big fields, estimates their environmental impact using scientific sources, and also evaluate how easily each change is to be implemented. We will now present 2 examples from 2 fields. Let's start with sustainable energy use. Keeping a smartphone longer through repairs, hand purchase, and/or better battery care. This can make a major difference because most emissions are proven to come from manufacturing or production. Over the 6 years of study, students could save approximately 148 kilogram carbon dioxide equivalent. While this change may not always feel like the cheapest or most convenient option, it is highly accessible and easy to adopt within existing systems.
Our app also focuses on students as fashion consumers. In the clothing category, we suggest 6 different lifestyle changes, and one of them is buying secondhand clothing. According to multiple reports, about 80% of a garment's carbon emissions happen during production, which means most of its environmental impact happens before we even wear it. Based on published carbon emission assessments, we estimate that a student who avoids buying new clothing during their studies can save over 500 kilograms of carbon emissions. Looking at the ease of implementation, buying second-hand clothing is very affordable and widely available both in stores and online. However, some students may feel uncomfortable wearing clothes that were previously owned by someone else. Suspaka acts as a guide to a more sustainable lifestyle, especially for today's generation of students. Through the app, users can access a variety of simple sustainable actions, all supported by clear scientific information, set daily, weekly, or yearly goals, and get reminders to stay consistent, and stay motivated through our Alpaca coin reward system, where they can customize their alpaca and track their progress. Thank you so much for your attention, and we invite you to scan our QR code for having a preview on our Suspaka mobile app.
Thank you very much. We will now have 1 minute for questions from the judges, if there are any.
There are no questions. I have a question. So is this app something you're gonna like try and implement and bring to like the App Store or something? Because this is very cool.
It would be nice, yes.
Awesome. I think we have something similar going on at Case Western Reserve University. I've seen people using this, and they have a Thrifty app or something like that.
Yeah.
Very cool.
Very cool. Thank you so much. If there are no other questions, I think we're gonna give a second if the judges want to get caught up and they're all good. Once I get a thumbs up from the judges, we can then move on to the next group. Thank you so much for presenting.
Bye.
You will want to stay on till the end of the event because we are going to announce our
we'll
winners.
announce
Yeah.
Yes, we will announce later. Awesome. Cool. With that, I think we can move on to the next presenter. That should be David Patron.
Yeah, right.
You are sharing. Awesome. Cool.
So you can see and hear me?
Yes, we can see and hear you. So go ahead and get started whenever you're ready.
I am ready, so let's start. So thank you for the invitation, and good afternoon to the US people and good night to my Germany people. We will already have very sustainable sleep tonight. But anyways, very happy to join the Sustainable Symposium and having the chance to present online. We all know these goals shown by the UN on sustainable development. And what is interesting to see is that sustainability is not only about what we're talking today, but that sustainability reaches everyday life, including impact on people, prosperities, and partnership. And this is what is somehow part of our group or become part of our group because we are part of a university-wide Cologne sustainability initiative. And we have combined all our chapter activities in the so-called Rhine ceramic chapters, including our ACerS, MRS, and ACerS chapter. And this is important because we are a group which is working on sustainable materials, sustainable ceramics, thin film modification. So overall, our group is trying to improve minimization of materials, of expensive materials and critical raw materials all over in the research, and doing this in several topics. But how are we implementing this? So I think most students in Germany, so this is not general for everybody around the world, but you need to look what is around you. You should take chance on the activities, sustainable activities given to you by your city government and so on. For example, Cologne is pushing very hard the infrastructure on bicycle roads. And I think this is one of the easiest way to go emission-free. And at the same time, we will be happy to save some calories. Another example is the Germany ticket. This is an initiative by the German government where every student basically has a ticket to take open mobility for free or have it integrated in their semester fees. And just having as an example, taking the bus instead of the car could save half of the gram per passenger per kilometer of CO2 per every single kilometer made. And another initiative by the Cologne University is the Campus Green, which means that our cafeteria always offers a vegan alternative to a normal price, so not much more expensive than the other products. And this is important because we can see that those small things, again, meat versus vegan, has almost half of the weight of CO2 per year by just going through this meal. So very big impact through small actions. And the most important thing here is don't complain, give it a chance. We can talk about sustainability, but at least those small actions we should take. Another is what we're doing at lab scale. Of course, we're trying to save processes as good as possible. Solvent recovery, waste recycling, and industry is a big thing. So we're trying to minimize or to integrate this in our everyday life as well. Talk to your colleagues. These are just two simple processes where we are trying to recycle something that we're using. For example, we're using our dry ice mixtures again and again. The alcohol will not evaporate. The dry ice will go out as CO2. So we can use the alcohol again, not maybe for synthesis, but at least again for the cooling system. And same we do with our battery waste. Our sodium chunks we can reuse as drying for solvents and so on. But the major part that I want to show you is because I showed you that we are very active chapters. And I think that this is something that really can help to promote sustainability, become part of a chapter of a society. ACerS is just one example, and the PCSA as well, which is the student society, because through these societies, you can get outreach for yourself, for your group, you can teach sustainability, and the best is you can get happy people and kids. Of course, you have to, the biggest waste is your time. You have to give it a chance, but you will have the biggest impact by just doing this. Here is a link, for example, by the PCSA, people who support you in the overall, in promoting such kind of thing. And with just a little of efforts and time that you give from your side, you can have a big impact on a lot of people in very short time. And with this, I want to thank you.
Thank you so much, David. All right, do we have any questions? We're going to do a 1-minute question period now. Going once. Yes. Oh, yes, you're not talking microphone.
Could you maybe repeat the question?
Sorry,
because
technical difficulties really quick. We're just figuring out the microphone really quick. Sorry. Yes, that would work. Yeah.
My question is, have you quantified the financial impact of the recycling practices in your lab? Like, do you have a number for how much money you've possibly saved through the recycling, or is it just quantified through those sustainable metrics?
Honestly, we have not calculated that yet. I can just comment on the sodium chunks, for example. We save by producing them ourselves because we save a lot of cost by just not buying them, but producing the chips for our batteries. And the waste is huge, both when buying them and when using it like that. So we have never calculated it, but it is definitely worth doing it.
Nice, thank you.
Is there any other questions? Awesome. With that, thank you so much, David. I think we'll move on to the next speaker, which is that's going to be Felix Dietrich. So, Felix, are you on?
Awesome. I'm online, yes.
Awesome. Whenever you are ready, then.
I'm ready. I hope you can see my screen.
We can see.
We see a white screen right now.
There is a figure in the top right, but...
Yes, exactly. Thanks, okay.
Awesome. Cool.
So, hello everybody. My name is Felix. I'm from Darmstadt in Germany. So, climatic change, conflicts, political instability, housing crisis, it often feels like the stream of bad news never ends. And many of these challenges are deeply connected to sustainability. The key issue is not a lack of knowledge, we already understand the problems, but the knowledge rarely translates into action. So the question is, how do we turn knowledge into action? Not through more theory, but by making sustainability something people can actually experience in their everyday lives. What if sustainability wasn't just something we're talking about, but something we live together? The idea behind is Colversity. Colversity is a student-led space where sustainability becomes part of everyday life. It is a place where sustainability is lived, learned, and shared. And importantly, it is open not only to students, but also to the local community. Creates a space where both can learn from each other. At Colversity, learning works in both directions. Students bring the academic knowledge and skills, while the local community contributes real-life experience. This creates a system of two-way learning, not top-down, but collaborative. And this exchange becomes tangible through concrete activities, preparing instead of replacing, sharing instead of owning, and learning by doing. For example, through repair cafes, bike workshops, discussions, and second-hand events. In this way, sustainability is no longer abstract. It becomes part of everyday life. This approach creates real impact by turning sustainability into daily habits. It lowers the barrier to participation and builds strong connections across different groups and generations. Of course, there are challenges, especially organization, funding, and maintaining long-term engagement. However, the concept remains highly feasible because it builds on recycling spaces, student groups on campus, and local networks. So ultimately, Coalversity is about one key shift from awareness to action. Coalversity. Thanks.
Awesome.
Thank you for
so
your attention.
much. Yes. 1 minute for questions. If anyone has questions. Yes. Hopefully this mic works.
Thanks. Oh, you can hear me. Excellent. So you mentioned that this is a physical place where you can have different kind of sustainability activities. Have you had repeat people attend these events, and have you noticed, or do you have a metric of increasing the population that attends these events?
Yeah, for example, in Darmstadt, we have some of these activities already built up, like a bike workshop or also like repair cafes, and it works very well. So, of course, it's not every day some events happen there because, of course, not every day you can attend there and stay there, but they are mainly open some days a week, and so you can start to build up this community and the stuff together. And I think a central place that it's driven by the community itself, by the students, it was really nice and gave a lot of benefits.
Fantastic. Thank you.
Very cool. Yes. Thank you so much. Are there any other questions? If not, I think we'll move on to our next speaker then. Thank you so much, Felix.
Thanks.
Our next speaker will be Yara Gomez. Are you online? Hello, Yara Gomez. Oh, perfect. Okay. If you are talking, we cannot hear you.
Can you hear me now?
Yes, we can hear you now. Yes.
Oh, okay.
Awesome.
Okay, let me get back to the... Can everyone see everything?
Yes, the presentation is coming through. Whenever you are ready, you are welcome to get started.
Okay. So, hello everyone. I'm Yara. I'm a master's student from University of São Paulo here in Brazil. The project that I'm going to present today to you is called Growing, Shifting Student Lifestyles through Cooperative Gardening. So, I have 3 proposals for you that are actually connected to each other. The first one is based on the garden, the campus garden, that's going to use a group of students using a problem-based learning methodology to give life to this garden and keep it going. And as a third proposal, we also want to engage the community to create a sense of social responsibility. And we can do this from the group and the garden itself. So it's kind of everything connected. My presentation here is going to be divided into the part of impact and ease of adoption. If it's green, I mean it's good. Yellow, it's a place for discussion. Red, it's a difficulty that we have to overcome. But the biggest impact is that once the student learns how to take care of the garden at the campus, it could be replicable at home. So we, in fact, have a lifestyle change. Here in Brazil, this would be very applicable because we have good climate conditions all year. And it would be scalable depending on how many students adhere to this idea. So you could have either small groups or in a project scale or even a campus-wide All of this keeping a same workload of 3 hours per month, and with a very low cost that could be acquired through crowdfunding, for example. Of course, if you get a bigger project, then you have to have a dedicated area for this, but this could also be overcome in Brazil because we have a lot of agriculture courses in this campus, and sometimes you already have the areas for this, so it would be easy to apply. So the center will be this problem-based learning engagement between the students, where we have the diffusion of knowledge in the sustainable practice and a bigger interaction, of course. But we know that when it comes to groups of study, if you keep on the theoretical realm, this could lead to demotivation. So the garden serves as a tool to counter this effect because you have the practical learning from the episodes that happen in the garden, right? And if you expand this to the community, we now break out of the academic bubble. We're strengthening the sense of social responsibility, and then we engage more people, of course. But again, we have to have the interest from the community. And here in Brazil, since we have very diverse campus, we can attack different areas to get interest from more people. So from the social realm or the health courses or the science courses, everyone has something to offer to the community that could make this more attractive. So if you get this 3 hour workflow that we estimated, we would spend most of the time in the problem-based learning methodology to solve problems in the garden and learn how to take care of the garden. The garden itself is the basis as like 1/4 of the time that you actually have to maintain it. And some small part, like 1/10, would be dedicated to the community, so you can expand this. So that's it. Thank you very much. I would like to thank the people that helped me come up with the idea and make it more concrete. And I'm open to your questions right now.
Awesome. Thank you so much. Do we have any questions? Yes.
Thank you so much. When it comes to the space issue, how much space do you think you would need per square foot or per square meter? And have you considered something like a vertical garden to maximize your production per unit area?
Yeah, so we have some estimatives here on how much we could produce per square meter. I think it's close to 6 cycles per year and 4 kilograms of food, depending of course, what you produce. And depending on the space that you have, you could that's the thing about this project. You could adapt like for doing it in an office or in a big field or in a vertical garden. Vertical garden is actually something that I already applied in a school project when I was very young, and it worked very well. So yeah, that's the thing. You could go into a lot of areas and a lot of different solutions for different campus.
Very cool. This makes me want to start my own garden. All right. Thank you so much. If there are any other questions? I don't think so. With that, thank you. I think we're going to move on to the next speaker now. Blessing Masanga.
Yeah,
Blessing, are you there?
Yeah.
Perfect. Awesome. You can share your screen. That'd be great.
Yeah.
Awesome. Cool.
Can everyone see?
We can see the screen and we can hear you. So whenever you are ready.
Okay, hello, my name is Blessing Masanga. I'm a freshman student from Western Reserve University, and today I'll be presenting to you sustainability by default as a concept where I'll be emphasizing that students don't need more awareness about sustainability, but what they need is better systems to become more sustainable. So the real problem and the issue I've identified is that like we keep asking students to try harder every day. Like we have more awareness campaigns, we have more pledges, and we have like more guilt tripping, but we fail to realize that the willpower for them to become sustainable is not like a sustainability strategy, but if we make our systems better, that will enable the willpower. And the four main issues I'll be focusing on this presentation is food waste, move out waste, and also textbook waste. So the first solution I'll be suggesting is a shadow library where it's a more decentralized student-powered textbook sharing kind of system, whereby it will be new in a kind of way that it's just not like a normal library, but it will be like a peer-to-peer network where books will be flowing between students. For example, if you finish taking a class, for example, right now I'm taking a discrete mathematics class, and the book I'm using, I borrowed it from someone who took it last year. So the impact of this is that students spent between $400 to $700 to buy books, especially in USA. So they'll be saving on that much money. And also it will cut on demand for new prints whereby publishers publish new editions of the book every year or every 2 years in order to cure yourself. And a barrier to this will be trust, whereby students who are renting their books will be worried about the condition in which their books will be returned. But this can be enabled through a peer review rating, and also a deposit system where students will be able to deposit money, and also penalties when the books are not returned in a good situation. The second solution that I'm proposing is a kind of a rotating wardrobe, whereby imagine Netflix but for your clothes, especially when season changes, with fast fashion, students tend to buy more and more clothes each year, and you just have more clothes that you buy you wear only once or twice and then you don't wear again. So this will be a system where students will be able to share their clothes online, and then they'll be enabled to swap the clothes with other students. So this will be able to extend the lifespan of clothes by 3 or 5 times, and also to save on money that they are using to buy new clothes. A barrier to this will be stigma about secondhand clothes, where people frame it like charity, but an enable to that can be brand it as a style, where most people you have clothes but you don't have anything to style it with. So if you get something else you can style it with, which you don't buy but you swap with someone else, it will be an upgrade more than a sacrifice. The other one is circular moving, where we see a lot of waste being produced around move out time, which is around this time. So if people who are moving out can log in their items to a system whereby students coming in can be able to rent those items, it will reduce immensely the waste produced at the end of the year. And this will prevent, of course, the ton of waste that is produced at the end of the year. And it also cuts on moving costs for first year students, because I remember for me when I came in, I spent almost $500 trying to set up my room and get every domestic essentials I wanted. A barrier to this would be inventory tracking, whereby we'll have a lot of things coming in, and then you won't know won't be able to keep track of which is in good condition and which is not. So it will need to involve a lot of coordination and a lot of people, but it can be enabled by yep.
You can finish if you'd like, if it's 1 or 2 more slides.
Yeah, so I have one more slide. It will be enabled by a QR code system. And the last solution I'm proposing is a food waste reduction, whereby I'm redefining food waste in a way that people always think about food waste where they focus on the food people eat and the amount of food people eat, but we have to think about eating as a social concept, whereby if you eat with people in in a social setting, you're more likely to waste less food, because you get less portions, and also you'll be more likely to finish the food you eat, more than if in college setting, if you take the food you're eating back to your room, it you're more likely to not finish that food. And also ordering food at midnight is those kind of things. And this will be enabled where sharing meals is cheaper, and also it can enable deeper relationships and more healthy mental health in college students. So yeah, those are my 4 solutions, and thank you for listening to me. I'll take any questions.
Awesome. Thank you, Blessing. Do we have any questions about those? If not, we're going to move on to our next speaker, who is
Do we have any questions from the online audience?
From online, yes. I keep on forgetting to ask about that. I think that is a no. If not, we're going to move on to our next speaker, Vingkan Liu. Are you online? They're not here. Okay. if that is the case, we are a little bit ahead of schedule. They're supposed to present at 4:55, so they've got 3 minutes. But
sorry, it's me or it's I didn't like hear like the name.
Vin Kong Lu.
I know. I think Yifan should be last one. Sorry.
Yeah, Yifan, you're at the end. You're one of the later speakers. Okay, so I think Vin Kong is not here right now. Then, so
we can move on to the next speaker if they're ready.
Shiva Sai, are you here? Okay.
Hi.
They're not. Oh, Shiva, you're here. Yeah. We'll go ahead and have you present then, if you're okay with that.
Okay, I'm starting.
Awesome.
If my screen present to you? On?
Yes, your screen is yoga.
Hello. Okay, thank you. Good evening to respected chairperson, guests, and fellow participants. Firstly, I'd like to thank you for all giving this wonderful opportunity. Let me introduce myself. My name is Yosei. I work at CMET Hyderabad at COE. Today, I am representing the overview on e-waste recycling process for strong sustainability. Here we can see 4 major e-waste uses that we have. Technology for recycling. Spent PCB, spent lithium-ion batteries, spent solar cells, spent permanent magnets. Here we have 5 various verticals of COE. V1 as lithium-ion batteries recycling, and V2 as permanent magnet recycling, and V3 as PCB recycling, and V4 as solar recycling and skill development. And I work on lithium-ion battery recycling. Here, the Ministry of India has released 30 critical minerals on the day of 24th July 2023. Among them, we recycling up to 8 minerals like cobalt, nickel, graphite, lithium, copper, silicon, and rare earth elements. First, we go for PCB recycling. PCB is used to connecting electronic components. Recycling of PCB by collecting electronic gadgets, and then we dismantle, and then we go for depopulation, and then we go for shredding, and then feeding for smelting and casting the electronic refining, and then go for anode mode leaching. Then we can collect or recollect the elements like iron, copper, gold, silver, aluminum, and more elements. And then we move for recycling of lithium and batteries. India's National Electronic Mobility Mission plans aims to achieve the large scale of adoption of electric vehicles by 2030. This creates the huge demand of batteries. Here, the elemental compositions of lithium-ion batteries, where lithium contains 2 to 8% and cobalt content 10 to 25% and manganese content 8 to 15 to 14% and nickel contains 3 to 10% and metal fractions like nickel, copper, iron, aluminum 5 to 10% and steel casing up to 10 to 15% and plastic fraction about 3 to 7%. Here we can recycle the lithium-ion batteries in hydrometallurgy as well as pyrometallurgy. First we go for hydrometallurgy. We collect lithium-ion batteries, end of lithium-ion batteries, then go for neutralization and commutation and size classification. Here we separate the metal fraction as well as plastic fraction from the black mass, and then we go for thermal treatment. Then we will leach the black mass for extracting lithium as a lithium carbonate, and then whatever residue left over, it presents the cobalt, nickel, manganese, and as well as graphite. And then after acylation of the residue, we collect graphite, and after that, solvent extraction. After solvent extraction, we can collect manganese, cobalt, nickel in an oxide form. Here you can see the valuable recovery of lithium-ion batteries. We can collect up to 4.5 kgs of lithium carbonate and 23 kgs of cobalt oxide and 3.5 kgs of nickel oxide and 10 kgs of manganese from the 10 kgs of lithium-ion batteries. And also we can convert
Are you still there?
So that's also time for your presentation.
carbonate into lithium hydroxide, nickel oxide. Almost
That
near.
is 4
And also we
minutes.
have pyrometers.
Excuse me, sorry to interrupt. That is 4 minutes. If you have one or two more slides, we can finish them. But if not, if it's a lot more, I think.
I will like complete in a minute. And we have also pyrometry. We can go through thermal treatment.
Okay.
We can collect cobalt and nickel oxide.
I think we're gonna call it there, and move on to the next speaker, if the next speaker is ready. Thank you so much for your presentation. Are there any questions as of now? I think that is a no. Any questions online? I think that's no as well. All right, our next speakers, they might not be ready yet, but our next speaker is Gautam, Rushanath, and Sandvidi. Are you guys here?
Yes, am I audible?
If you guys are here and you're ready to present, we can have you present now. Are you okay with that?
Yeah, I'm Gautam. Like we are joining in the same device.
Oh, awesome. Okay. So if you guys are ready now, you can share your screen so we can see the presentation.
Is my screen visible?
Yes, we can see the presentation.
I'll start my
Awesome.
presentation now.
Yes,
Good day to everyone. It's a pleasure to be a part of this webinar. Like we are a group of MS students from IIT Madras. And we are excited to share our proposal with you today. From the start, our goal was to design a solution that is truly inclusive. We have focused on creating a framework that every university, regardless of its tier, ranking, or funding levels, can successfully implement. So we believe great innovation should not be limited by resources, and we look forward to showing you how this work can be done. So moving on to our first idea, which is energy credit system. So how this works is like we install a digital dashboard in a campus common area. So for example, let's take a 3 hostels in the campus. Like people will use energy. Like what we'll do is we'll display the energy they are using per person. So at the end of 3 months, we will have 3 tiers, which is like diamond, gold, and bronze. Like let's say diamond is like the minimum usage of the current, whereas gold is the second, and the bronze is the third, which is the more currently used by them. So according to that, the hostel will get some reward points. So with that reward points, the students can purchase something, let's say gym equipments in the hostel. They can also celebrate some hostel nights, and they can get some utilities in hostel and so. So it's a win-win situation for students, institute, and planet, because as a student, you get credit points by saving power like electricity. For institute, it reduces utility cost and boosts SDG ratings such as 7 and 12. And for planet, the carbon footprint directly gets reduced. So like it is also like it is shown that 1 kilowatt hour of energy can avoid up to 0.7 to 0.8 kilogram of carbon dioxide emission. Moving on to Rushinath.
Yeah, and the idea with which I came up with is hybrid renewable study pods. So it is nothing but creating small outdoor study spaces which are powered by solar panels and also small vertical axis wind turbine. So this will provide the charging, lighting, and also the collaborative seating for the students. So the pros are that we are using both solar and wind energy, and it also works during power cuts. And because of its visible sustainability, it will increase the awareness among the students, and it is scalable across the campus. And the cons are that solar and wind energy are not readily available every time. So, and also there is high initial cost, and the battery replacement is needed, and it also requires regular maintenance. And coming to the ease of adoption, we use the already existing technology such as hybrid solar wind technology, such as this street lights. The solar and wind street lights are being used in many countries, so we can adopt the technology. And also the process become economically profitable only if we use it in large scale, such as if we use the terraces for these roof tops study or sitting spaces, then it will be economically attractive, and it can also provide charging for laptops, phones, and also to get some fresh air in the evening or night. And we did the 15 years estimate, and it is reducing carbon dioxide by 27 metric tons, and it is also saving money. It's over to you, Selvan.
Our third idea is that to convert everyday movement into meaningful impact by rewarding students for walking and cycling. Like we know in campuses, some people are already
That's
having
4 minutes.
Okay.
That's a last slide. Like, can we take?
Yeah, you guys can
Yeah,
go
if you
on.
have one or two more slides,
Just
you can finish
go
them.
on with this slide, and that should be okay.
Okay. This idea is that students will earn points simply by choosing sustainable mobility, which they can redeem for campus benefits like they have cafeteria discounts and priority booking. So, and this idea also will have impact on planet, will lower the carbon dioxide emissions. So directly, this idea will support the seven of the 17 UN SDG goals, as such as 37 up to 17.
Yeah, like, thank you.
Thank you so much. I think our last presenter, actually, any questions? Sorry. Yes.
Yeah, I was just wondering, did you look at the potential loss in energy on the solar panels by adding the wind turbine on top? The shadow of the wind turbine would reduce the efficiency on the solar panels on the umbrella. So what kind of loss would you expect due to that?
Like actually, like it can complement the solar panels. Like solar panels are ineffective in night and also weak during rainy seasons. So at that time, maybe this wind energy can provide sufficient energy. And we are using this vertical axis wind turbine, and it is of low cost compared to horizontal axis wind turbine. So we can use it in complementary to solar panels.
Okay, thank you.
Yeah, thank you.
Thank you.
Are there any other questions online or in person? If not, we're going to then go to our last presenter.
Hello, I'm here. So I just share my screen.
Yes. Our last presenter is, sorry, give me a second, Yifan Liu. So,
can you see my screen?
Yes.
Yeah.
And then also,
Okay.
as just a quick check to see if he's here, Ving Kong Liu, is he here in the chat at all or not? Okay. Okay, awesome. Then whenever you are ready, you can proceed. Thank you so much.
Okay. Hi, everyone. I'm Ifan, a student researcher from the University of Cologne, Germany. So, and hi, everyone from Germany. Oh, everyone from US. I want to take you on a little journey today. I call it a microplastic day in the life of a student. So, we will say. Okay, so there's some research that we will take like 5 grams of microplastic a week. That means actually it's a credit card, and we also put a countless card into the environment without even realizing it. So the day of the microplastic day is like start from your 8 a.m. the morning brew, like when you head into the class, what's the first thing you want to have, like the coffee. So, but the classic liner is like you have the paper cup, but the paper cup also have the plastic liner inside. So with 15 minutes, there was like a 20,000 microplastic into your coffee. And if you have the tea bag, that's really brilliant. And then we will have 11.6 billion microplastic per cap. So the solution is very easy. Just bring your own cap, and also don't use the tea bag. Yeah, and then 1 p.m. is lunchtime. You as a student, like we always maybe prepare our own food. Don't want to buy any other food. So, but you grab your cheap plastic lunchbox and want to put them in the microwave. But the microwave actually will kind of like make a microplastic all the way into your food, and even you think like, okay, but I use like biodegradable plastic lunchbox, but actually it's an eco bubble because the PLA release up to 40,000 times more monoplastic than the regular plastic, and also because every plastic have to add on, and then including exactly same baseline toxicity as a normal plastic. So the baseline, the solution of here is like never microwave any plastic, even in the commercial way. They say, okay, we are really safe, and always transfer your food to ceramic or glass container. And then 6 p.m. the honey out time, and you think, okay, we are use like the paper straw, like we don't use like a plastic straw anymore, but actually the paper straw is same to the cup. They also have like a plastic layer inside, and also even there's research like actually they are all the new paper the paper straw actually have more PFAS than it's kind of like the very toxic endless substances, and then the like normal microplastic. So the solution is like just use steels or any like pasta to do that. So the 10 p.m. is laundering time, and the laundering time, when it's laundering time, so we normally will put like our clothes in the laundry and put like some softers to, because it's very, very fresh, and also make some nice scent boast beads inside. But scent boast beads basically just microplastic coated stuff, and they make a bead inside, and then use a software. They were over like 700,000 microfibers in the one per wash load. And so if you want to soften your clothes, you can use the white vinegar, maybe, but then the
That
only
is
thing we'll think
4 minutes. You can keep going.
almost finished.
Once
You sound you smell like a salad dressing. Yeah, that's it, and that's our reality. So I want to show it's like we are leaving our footprint, but as we said, like you can shrink your footprint today, and just a simple habit change, and then the market demand changing. Thank you. That's all.
Thank you so much. Are there any questions? Yes. Question.
Thank you so much. Have you weighed the pros and cons of doing the simple habit change versus the global convenience?
Yes, that is like I think that is like always the debate. Like if you want more convenience, or if you want a more to less footprint inside, and somehow we need to make this calculation, right? So to say which one is more like your cup of tea, and yeah.
All right. Thank you so much. Are there any other questions from in person or online? If not, I think we're going to do one last check for Vincong. Nope. Okay. We are very ahead of time. So, actually, wait.
Which is not a bad thing.
Which is not a bad thing, yeah. Actually, we are right on time, actually. So with that, we're going to have the judges, we're going to give them some time to deliberate. There is a form. If you are in person or online, please scan the form and vote for the presentation you thought was the best. There's first place, second place, and third place. Please pick one for each, and we'll do voting based on that. So if the judges want to get together and deliberate, that would be great. From that, we're going to just give them some time to do that. So thank you so much.
And while the judges deliberate and the audience votes, I would like to thank everyone who participated, irrespective of whether you win or today. I saw many dark backgrounds, so I understand it's very early morning in India and Europe also. It's like in the middle of the night. Thank you very much for bearing with us and giving us these very nice presentations.
Yes, thank you for participating. Thank you also to ACerS for allowing this to happen. Thank you to the Symposium for letting this happen. Thank you to ACerS and EDIV both for funding this. Thank you to Vicky for managing the entire online aspect. So thank you all.
Vicky, did you vote? Did you vote, Vicky? Oh, you. Are the mics off? No, the mic's working.
Oh, awesome. Okay. So the results are in. We know who won for the judged and audience choice categories. Just a reminder, for the prizes in both categories, first place is $300, second place is $200, and first place is $100. Thank you all so much for competing. Thank you to our audience for being here. Thank you to... yes, can we have the people on Zoom? Or yeah, okay, awesome. Yeah, thank you to ACerS and Edith for funding this. Thank you to the Symposium for having us. Without further ado, I'm going to introduce Professor Borgia, former president of the ACerS, to come up and announce the prizes. So thank you so much.
I need to get my glass.
I can also get your glass.
Sorry about this.
No worries. Second.
I think we will bring your glasses.
Is this readable?
Yeah. So the first place goes to Yara Gomes, and this is in both the categories, the judged category as well as the audience choice category.
Yara, are you still there?
Hey, I am.
Congratulations.
Congratulations.
Thank you very much, everyone.
The second place goes in the judged category to Dora Ailes and Stalinta Sachai. And in the audience choice category, it is Felix Dietrich.
Thank you so much. Thank you.
Thanks.
And the third place in the judged category is Felix Dietrich, and in the audience choice, it is Yifan Lu. Congratulations to all of you. And congratulations to all the participants. Thank you for competing in this. It was a lot of fun. Thanks.
So have a good morning, good afternoon, good evening, and good night wherever you are. See you all in the next meeting.